This is Mission Control, SRB, SEP confirmed, velocity 4,300 feet per second, Atlantis downrange 35 nautical miles at an altitude of 30 nautical miles. 3 engines all looking good at 104%.
Atlantis, performance nominal.
This is Mission Control. This is Mission Control. That call lets the crew know that the SRBs and engines are providing the expected thrust.
Atlantis, 2-engine Ben Guerrier.
Atlantis, Roger, 2-engine Ben Guerrier.
That call means that Atlantis could make it to the transatlantic abort site on only 2 engines should that become necessary. Velocity now 5,600 feet per second, downrange 84 nautical miles at an altitude of 47 nautical miles. All 3 APUs still looking good. 3 engines at 104%.
Atlantis, negative return.
Atlantis, Roger, negative return.
That call signifies that Atlantis could no longer return to the launch site. Atlantis now traveling at 7,300 feet per second, downrange 137 nautical miles, altitude 55 nautical miles. This is Mission Control. Atlantis now at 8,300 feet per second, downrange 172 nautical miles, altitude 56 nautical miles. Our next call that we're expecting will be the call for press to MECO, which will be at 6 minutes, 10 seconds mission elapsed time.
Atlantis, press to ATO, select Banjul.
Atlantis, no go.
The press to ATO call stands for press on to abort to orbit, should that become necessary. Currently all engines performing at 104%. Atlantis velocity now 10,400 feet per second. Downrange distance 246 nautical miles.
Atlantis, droop Banjul 109.
Atlantis, Roger.
Atlantis, press to MECO.
This is Mission Control.
Atlantis, Roger, press to MECO.
This is Mission Control. That call means that Atlantis could press on to main engine cutoff. Velocity now 1,200 feet per second. Correction, 12,000 feet per second. Downrange 300 nautical miles. Altitude 58 nautical miles.
Atlantis, single engine Banjul 104.
Atlantis, Roger, single engine Banjul 104.
Atlantis could now reach the landing site at Banjul in the Gambia on 1 engine. This is Mission Control. Atlantis now traveling at 14,000 feet per second, downrange 388 nautical miles, altitude 57 nautical miles.
Atlantis, single engine press 104.
That call indicates that Atlantis could
Single engine press 104.
that Atlantis can press to orbit on 1 engine at 104%. All 3 engines are performing at 104%. Atlantis velocity 18,000 feet per second, downrange 510 nautical miles, altitude 56 nautical miles. This is Mission Control. 3 engines begin throttling back to protect for the 3G limits on the vehicle. Velocity now 21,000 feet per second. Downrange 600 nautical miles. Velocity now 2,300 feet per second. Downrange distance 699 nautical miles at an altitude of 59 nautical miles. This is Mission Control. Main engine cutoff has been confirmed. And
Atlantis, Houston, we see a nominal MECO, nominal ohms 1, on time.
This is Mission Control. Separation from the external tank has been confirmed.
Roger, R1U fail off, no action. Atlantis, you copied nominal ohms 1 on time?
Atlantis, roger.
This is Mission Control. The guidance officer confirms that Atlantis is maneuvering to the burn attitude. The ohms 1 burn will be at its planned time of 10 minutes 39 seconds mission elapsed time. The duration of the burn will be 2 minutes 26 seconds, and the delta velocity will be 227 feet per second. Flight Dynamics Officer also confirmed a nominal MECO time, and the Guidance Officer confirms the vehicle is at the burn attitude. This is Mission Control. Propulsion Officer confirms both ohms engines are burning and the burn is looking good. This first ohms burn will put Atlantis in an elliptical orbit of 160 nautical miles by 65 nautical miles. The ohms 2 burn, scheduled for 44 minutes mission elapsed time, will circularize the orbit at 160 nautical miles. This is Mission Control. A propulsion officer confirms ohms engines have cut off.
Atlantis, Houston with you through Tidris. Looks like a good burn. Your go for APU shutdown on time.
Roger that, Frank. Burn was nominal. Thank you much.
And Atlantis, your ohms 2 will be nominal on time.
Atlantis, roger. Nominal ohms 2 on time.
This is Mission Control. Following a good ohms burn, the crew's been given go-ahead for shutdown auxiliary power units at the scheduled time. The second ohms burn is planned for 44 minutes mission elapsed time. That burn will be for a duration of 2 minutes 8 seconds and will be 195 foot per second burn. This is Mission Control. The Mechanical Systems Officer verifies that all 3 APUs shut down as scheduled. Following a very nominal ascent, crew of Atlantis proceeding through their Ascent checklist as they begin preparations for their first day working on orbit. The next order of business will be the second ohms burn at mission elapsed time of 44 minutes and 28 seconds. That burn will use both ohms engines, burning for a duration of 2 minutes and 8 seconds with a delta velocity of 195 feet per second.
Houston, Atlantis, we got an APU thermal message. We've seen no parameters out of limits. We're taking no action.
Atlantis, say again.
Roger, Frank. We got a momentary APU thermal message. We've seen no parameters out of limits. We're taking no action.
Roger, we concur, no action.
This is Mission Control. That APU thermal message is no action required. MAX officer confirms that's due to the pilot's action of turning the controllers off, so there's no problem with that. This is Mission Control Houston at a mission elapsed time of 20 minutes. MAX officer confirms that the orbiter external tank umbilical doors are closed and latched. The next event will be a conclusion of the main propulsion system vacuum inerting. This is a procedure that vents the remaining residual propellants from the main propulsion system.
Atlantis, Houston, we see your targets loaded and we like the solution we see.
Okay, Frank. Thank you much.
This is Mission Control. The Capcom's conversation with the crew of Atlantis discussing the targets for the OMS burn. The second orbital maneuvering system burn is scheduled for 44 minutes mission elapsed time. And the crew will be maneuvering Atlantis to the proper attitude for that burn within the next few minutes. This is mission control during the ascent stage of the mission. The only failure noted here in the flight control room was a failure of one of the RCS jets, R1U. That jet failed off, but there's no action on it. There are numerous other redundant RCS jets that can be used while the vehicle is on orbit for maneuvering purposes. This is mission control. The guidance navigation control officer informs the flight control team that Atlantis has maneuvered and completed the maneuver to the burn attitude at 28 minutes mission elapsed time. Expecting the OMS 2 burn at 44 minutes mission elapsed time. The duration of that OMS 2 burn is 2 minutes and 8 seconds, and the delta velocity is 195 feet per second. Everything looking good on Atlantis. One small problem during the ascent phase was the failure of one RCS jet, which is numbered R1U. However, that requires no action by the crew or ground controllers, since there are numerous other RCS jets which can be used to maneuver the vehicle while it's on orbit. At about 16 minutes mission elapsed time, the crew got an APU thermal message. However, that was caused by the action of turning off the controllers, and the mechanical systems officer determined that no action was required for that message. Following a lengthy hold for weather, Atlantis got off right on schedule once we resumed the count from the T-minus 5 minute mark. And the unofficial liftoff time, Central Daylight Time, was 1:47 p.m. This is mission control at mission elapsed time 36 minutes. Quiet in flight control room 1 here at the Johnson Space Center. All systems aboard Atlantis continuing to perform normally. The crew has maneuvered the vehicle into the correct attitude for the second orbital maneuvering system burn. And that burn is scheduled at mission elapsed time 44 minutes 28 seconds. The two OMS engines will burn for 2 minutes 8 seconds duration, creating a delta velocity of 195 feet per second.
Atlantis, Houston.
Houston, Atlantis, go.
Roger, we just sort of missed the sound of your voice and wanted to let you know we're about 5 minutes from LOS, and we'll see you on the west side at about time 0+50, post-OMS 2.
Roger that, and 4 of us are very happy to be back in space, and the 5th one is very happy to be here.
It's almost time for a maggot check, I guess.
And Norm beat him to the first sandwich, so he's moping.
We all understand that.
This is mission control. We've lost voice contact with the crew through tracking data relay satellite east, but we'll pick up again on TDRS west in about 7 minutes. During the LOS period, the crew will be performing the OMS 2 burn, which should start about 1 minute from now. That second OMS burn is designed to circularize the orbit, which is currently at 159.8 nautical miles by 50 nautical miles. It will raise the perigee side of the orbit to 160 nautical miles circular. Following a very normal ascent with liftoff, unofficial time 1:47 p.m. Central Daylight, Atlantis easily made it to orbit, and all systems have been performing nominally. No problems are reported with the vehicle at this point. Flight controllers here in Mission Control are assessing their systems in preparation for giving the crew the go for orbit ops when that time arrives about 1 hour and 30 minutes into the mission. When we return to voice contact with the crew on TDRS West, we will get a report about the ohms burn. So far, everything is looking good on mission STS-30. This is Mission Control at mission elapsed time 44 minutes. This is Mission Control. The Integrated Communications Officer suggests that the static we're hearing on the air-to-ground circuit right now will probably clear up sometime within the next 10 minutes, although it's likely that the static could go on for at least the next 10 minutes. We expect to be able to talk to the crew again very shortly. This is Mission Control. The propulsion officer confirms that he's gotten enough data since we've been back on signal with the Atlantis to determine that we had a good ohms 2 burn. Everything is looking fine aboard Atlantis right now, and the vehicle is in a 160 nautical mile circular orbit.
Atlantis, Houston, we're back with you through TDRS West. How do you read? And do you have a burn report?
Loud and clear, Frank. ohms 2 is nominal.
That's good to hear. Congratulations.
Thank you, sir.
Atlantis, Houston, everything down here looks real good to us. You have a preliminary go for orbit ops and getting out of the suits?
Atlantis, roger. Thank you, Frank.
This is Mission Control. All the systems aboard Atlantis are performing very well. Crew has received a preliminary go for orbit ops. The formal go for orbit operations is given at a mission elapsed time of about 1 hour and 30 minutes, which would be about 35 minutes from now. And the crew will begin working on their post-insertion summary timeline, which is a short timeline used from 50 minutes mission elapsed time through completion of the early on-orbit activities. The crew will be removing their launch entry pressure suits and stowing the mission specialist chairs. They face a busy work day ahead on flight day 1. The scheduled deploy for the Magellan spacecraft is just shortly after 6 hours mission elapsed time. And the payloads officer has confirmed that both the payload and the inertial upper stage, which will propel it into a higher orbit, are both looking very good. And the Magellan payload control folks and the IUS payload control folks are pleased with both of those systems. This is Mission Control at mission elapsed time 1 hour and 12 minutes. The Data Processing Systems Officer has notified the Flight Director that the crew is performing systems management operations on one of the computers. This is one of the regular, ordinary procedures done shortly after the crew is on orbit to begin their work aboard the shuttle. Crew is progressing through their post-insertion timeline, and the next activity we will expect to hear about both from the crew and ground controllers will be payload bay door activation. We have received an official launch time. That was 1:46 p.m. plus 58 seconds. 2 seconds short of 1:47 p.m. Central Time. And to repeat the official launch time for STS-30, it was 1:46 p.m. plus 58 seconds. This is Mission Control. The guidance officer confirms that Walker has begun maneuvering Atlantis to the payload bay door opening attitude. This is Mission Control. The environmental systems officer has notified us that the crew has begun activation of the radiators aboard Discovery, so they are exactly on the timeline. And we will expect them to be opening the payload bay doors after they receive a go from Mission Control. This is Mission Control. The ECOM officer reports that we have good flow through the radiators. And we're expecting payload bay door opening activities within the next few minutes.
Atlantis, Houston, we saw good rad flow activity. We're standing by for payload bay door opening.
Okay, I understand we have a go to open the doors, and we'll be doing that momentarily.
Roger that.
And Houston, Atlanta.
Go ahead, Atlantis.
Yeah, what did you guys show for an official GMTLO?
Roger. It's 124/18:46:58.975.
Close enough for government work.
Roger, did somebody win the pool up there? You had about 5 minutes left in the window.
Yeah, we don't want to push it any closer than that.
Roger, we gave you about 4,000 pounds of extra performance doing that, though.
We're not complaining. We're really happy to be here.
And we're happy to have you there. I'm sure it looks great.
It's gorgeous.
This is Mission Control at mission elapsed time 1 hour 29 minutes. The mechanical systems officer reports that the crew has begun payload bay door opening activities.
Houston, Atlantis.
Go ahead, Atlantis.
I think we opened the doors and we had dual motor times on everything.
Roger, it looked great to us. Atlantis, Houston, you are go for orbit ops.
Atlantis, Roger. Go for orbit ops. Thank you, Frank.
Atlantis, Houston. Roger, we think we're UHF only right now for the moment. We'll be handing over TDRS east or west to east in about 2 minutes. Expect a short drop at that time, and we'll be going to high freak at that time also.
Houston, Atlantis, are you with us?
Roger, we have you loud and clear. We're just about to hand over. Stand by one.
Okay.
And Dave, we're in the handover now, but we do still have UHF if you have something to pass. Atlantis, Houston, we're with you through TDRS East now, and we have good data. How do you read?
Loud and clear, Frank, and a beautiful view of Florida coming by us.
Roger, and you look great going by.
And for those of us from that great state, it's quite a sight.
Roger, we copy.
Capcom, we're go to take the high load off, and then we'll be go
Atlantis, Houston, you've got a go for vernier ops.
Atlantis, roger. Go for verniers, and the maggot had something to say.
Yeah, Frank, for payload, we were wondering how Magellan did with interference with Milo this time, and whether or not they want me to send spacecraft discrete 1 at the nominal time, or if they're going to do something different from the ground.
Roger, stand by 40. Atlantis, Houston, for the maggot, everything is nominal. No lockup. Press on with the nominal timeline.
All right, copy, Frank.
Houston, Atlantis.
Go ahead, Atlantis.
Okay, dual motor time on the star tracker doors, and we have put them both in star track. We did get a fail on the Y tracker on the self-test, as we expected.
Copy, self-test fail on the Y tracker. And we're happy with the configuration, Dave.
Roger.
This is Mission Control at mission elapsed time 2 hours and 1 minute. Crew aboard Atlantis is continuing through their post-insertion timeline, just about to wrap up that activity. All the systems aboard Atlantis continue to function very well. Everything has proceeded as expected and as scheduled as the crew gets ready for their work on Flight Day 1, which is to deploy the Magellan spacecraft from the payload bay of Atlantis. Mission Specialist Mark Lee has sent the first discrete payload command and is already following the timeline for deployment of that payload. Flight controllers for the Orbit 2 team have arrived in Mission Control and are currently conducting their handover briefing from the Ascent flight team.
Houston, Atlantis for payload.
Go ahead, Atlantis.
Yeah, Frank, everything looks good up to sending spacecraft discrete 1, except the spacecraft amps are a little low at 7.8. I just wanted to verify that that was okay before I proceeded.
Payloads, spacecraft amps.
Stand by 1, Mark. Atlantis, Houston, for Mark. The Sunnyvale is looking at less heater activity than they had expected, and they're happy with the amps.
All right, copy.
This is Mission Control. That last discussion between the Capcom Frank Culbertson and Mark Lee about the status of the payload, and the IUS people at Sunnyvale confirmed that everything looks good, and Lee was given the go-ahead to proceed on the checklist for the payload deploy.
Atlantis, Houston, for Mark.
Go ahead, Frank.
Roger, on the top of page 2-9, can you confirm that the IUS auto shutdown primary is off and that the talkbacks are barber pole?
All right, that's in work, Frank.
Roger.
Houston, Atlantis for payload.
Go ahead, Atlantis.
All right, spacecraft discrete 1 was sent at 2 hours, 6 minutes MET. Everything looked good on board. Actuator is engaged. 1 minute, 35 seconds.
Roger, we copy all that. Atlantis, Houston.
Go ahead, Frank.
Roger, we'll be LOS on Tidris East in about 3.5 minutes. During the LOS period, we'll be handing over to Orbit 2. You can expect ratty calm on the other side, only because of your attitude, not the new team coming on. The Ascent team just wanted to tell you you look beautiful on launch, and we enjoyed working with you. Wish you the best on the mission, and Dave, personally, climbing into the cockpit, we couldn't quite come up with the word for how good you look.
Thank you, Frank. Thank the whole team for a great job. We really appreciate the fine support.
see you coming in.
Thank you.
And I'll...
Atlantis, Houston, 1 minute to LOS. We'll see you on the flip side at 2 plus 25, and wanted to remind you of the Radicom at that time. And one more thing, we just want to say how nice it was to have a red flash in orbit.
Thank you, Frank.
Atlantis, Houston, with you now through Tidris West.
11 clear, Houston.
Okay, read you the same. Good afternoon.
How you doing, Pierre?
We're doing great. Beautiful launch. Really enjoyed watching it.
We sure great from where we were sitting.
Roger that. Atlantis, Houston, a note on your R1U failure earlier. We determined that the oxidizer valve did not open. We're working on some modified RCS hot fire tests that we'll get up to you a little later. And we're not going to use that jet for the time being.
And copy that. Looks like R1U was a real fail-off.
That's firm. Atlantis, Houston, we have an orbiter state vector being shipped up to you.
Roger that. And Pierre, just a nit for prop. It looks like the right arm's fuel comp quit at 50. We suspect that it'll come up on the probe when we get down that far.
Okay, Ron, we copy that. Right ohms fuel quantity quit at 50. Okay, Ron, and we also saw that, and we also believe the aft gauge will work during when you get down to below it.
Roger.
Atlantis, Houston, we may lose you here. We're heading towards the tail. We'll pick you up in about 5 minutes if we lose you.
Roger.
Atlantis, Houston, got a couple notes for you. First, on panel L1, we'd like you to check the high-load duct heater to off. And then I've got a change to your AMU attitude for the sequence 3.
Okay, Pierre, high-load duct heater is checked off and ready to copy the attitude.
Okay, that'll be on page 3-10 of the IUS deploy checklist, step 5. We're going to change the maneuver attitude to roll 163, pitch 166, yaw 314. And the rationale is to ensure we'll have good comm with you at that due to the launch slip.
Okay, copy. The new attitude is roll 163, pitch 166, yaw 314, and copy. That's AMU attitude 3.
Roger that. And all your other attitudes are good.
Okay.
Atlantis, Houston, Sunnyvale has given us a go for internal power. We don't mean to rush you, but when you get ready, you have a go for that.
We copy that, Pierre. It'll be about 2-3 minutes.
Okay, that sounds good, Mark.
This is Mission Control Houston, 2 hours, 39 minutes mission elapsed time, all going very smoothly in Mission Control and aboard Atlantis as Magellan begins coming to life, as well as the inertial upper stage that will begin the journey for Magellan to Venus. The timeline that the crew and the Mission Control Center and the folks at JPL and Sunnyvale are following, everything going exactly according to plan so far. They've already sent one of the initial commands to Magellan, which begins bringing that spacecraft to life. That was a command called Discrete 1, and that turns on Magellan's recorders and heaters. Also, that command initiated the pin pullers for the solar panels, and the effect there will be to make sure that the panels are nice and toasty at their appointed time when they are to deploy during this procedure. Also, we're approaching a point now where they will begin the pre-deploy checkout for the inertial upper stage. as part of that procedure, the IUS will go on internal power. It will transfer to IUS batteries, and while the checks are underway, they will be on battery power, and then you'll hear Mark Lee call back and give us a duration of time for how long IUS was on the batteries. At that point, they'll be going back to orbiter power. And as best we can figure, the procedures now are roughly about 10 minutes ahead of time per the timeline, which is good. The Sunnyvale mission manager gave a go for internal power at 2 hours 39 minutes mission elapse time, and that go is nominally scheduled to come at just about 2 hours 45 minutes.
Houston, Atlantis for payloads. We're doing the transfer to internal power at this time.
I do that, Mark. Thanks. Atlantis, Houston, your go for the pre-deploy checkout.
Copy, go, pre-deploy check.
Mission Control, Houston, Sunnyvale has just confirmed good transfer to IUS internal power to the batteries aboard that spacecraft, and thereby giving us a go to begin the pre-deploy checkout. That was just passed on to the crew at 2 hours 45 minutes mission elapse time.
Atlantis, Houston, we're going to shortly uplink the AMU data take variable parameters list, so you'll see your flashing uplink.
Okay, thank you.
Atlantis, Houston, Sunnyvale confirms good pre-deploy checkout.
Okay, Pierre, look good here, and I'm going back to orbital power at this time.
Roger that.
Houston, Atlantis for payloads. We're back on orbital power. We are on internal power for 6 minutes. Command path enable is in RF.
Okay, Mark, we copy 6 minutes, command path in RF. Atlantis, Houston for Mark. Sunnyvale's ready to do their direct check, and they'll be doing it at Hawaii.
All right, I copy, Pierre.
Atlantis, Houston, for your AMU sequence, deselect IMU 3, and I've got a flight note, a couple minor changes to your IUS deploy checklist on page 54 and 627 when you get that out.
Okay, we understand. Deselect IMU 3, and we're going to page 5-4 in the IUS checklist now, Pierre.
And that's good copy, Dave. On 5-4 and on 627, there's a warning block, and it references IUS SSR1. Change the block 8 to block 9. There's 4 places, 2 on page 5-4, 2 on page 627. Also on page 5-9. And let me know when you get there.
Okay, we're with you on 5-9.
Okay, just delete the cabin to off for that electrical bus. I'm sorry, in step 5, payload cabin off, delete that step.
Okay, we copy, and we will not turn the payload cabin switch off.
That's good readback.
It's Mission Control, Houston, 2 hours 53 minutes mission elapse time, and Atlantis now passing over the coverage range of the Hawaii tracking station. The Sunnyvale team has been given a go from Mission Control to begin commanding to the inertial upper stage as part of the direct check. The direct check essentially a procedure to confirm capability of Sunnyvale flight to operate the command and control functions with the IUS from the ground. Also may have heard Capcom Pierre Thuet talk to Mark Lee about the attitude match update, or the AMU. Essentially that's a procedure to meet a constraint whereby Magellan is known to be sensitive to misalignment in the payload bay. If that were to be the case, its IMUs and those aboard the orbiter could be slightly out of sync.
Houston, INCO is going to select some payload bay cameras for us to look at the Earth with.
The result, if those IMUs were out of sync, would be slightly higher prop usage by Magellan on the way to Venus. So what we're doing is taking a data take on the orbiter IMUs, and if necessary, that will be given to the system to execute a much higher fidelity inertial measurement checkpoint later if necessary. It's probable that if the attitude match update technique were used at all, it would be used on a Flight Day 2 deploy were that to become necessary. At this point, it sure doesn't look at the procedures are going very well. The timeline is being followed point by point, and as we now look out of one of the payload bay cameras, Atlantis passing through coverage of the Hawaii station. We're at 2 hours, 55 minutes mission elapsed time, and this is Mission Control, Houston. We're now getting our first view of Magellan on orbit, snuggled in the payload bay of Atlantis. Now looking at the business end of the inertial upper stage Magellan stack. This is the nozzle for the solid rocket motor on the inertial upper stage, and the ring around it is part of the airborne support equipment, the tilt table that holds Magellan IUS in place in the payload bay. And as we move further down in the deploy timeline, we'll tilt the bird up and prepare to eject Magellan into low Earth orbit for the beginning stages of the trip to Venus.
Atlantis, Houston, Sunnyvale had a good direct check and their command is complete.
Okay, Pierre, we copy. We're proceeding into the IUS PI lock checkout.
Roger that.
This is Mission Control, Houston, 2 hours, 59 minutes, mission elapsed time. Sunnyvale Flight reports a good direct check between Vandenberg and the inertial upper stage. We're standing by shortly for a checkout of the payload interrogator, the system aboard the orbiter Atlantis, which will be sending RF signals to Magellan and will be one of the primary means of commanding to the spacecraft. As that begins, we will start losing our television signal, and we're standing by for that to begin right now.
Houston, Atlantis.
Go ahead.
We're ready for KU antenna deploy. If we could have the CCTVs, we'd like to record the deploy.
And Norm, we're done with them when you turn the FM system off. They're all yours. Atlantis, Houston, for Norm, do you copy? You can have the cameras.
Okay, Pierre, we're moving them around. Thanks.
Roger.
Mission Control, Houston, now at 3 hours, 2 minutes mission elapsed time. Mission Specialist Norm Thagard is beginning procedures for unlimbering the KU band antenna that will be moved outboard to give the antenna hardware the most desired thermal condition for the next several hours, although the antenna itself will not be powered up and will not be able to transmit live television pictures of the deploy.
Go ahead.
Okay, Pierre, you are after cabin pressure. Cabin pressure on the digital is reading 14.6. On the meter, it's reading 14.8, and we're doing PCS1 config.
Okay, Ron, we copy 14.6 on the digital, 14.8 on the meter.
Affirmative.
It's Mission Control Houston. Meanwhile, on the ground, our next television event will be a change of shift press conference with off-going Flight Director Lee Briscoe from the Ascent shift. We expect that press conference to begin at 5 p.m. Central Daylight Time, originating from Johnson Space Center's Building 2 briefing room. And again, that event upcoming in about 9 minutes on NASA Select. This is Mission Control.
Houston Atlantis for payloads.
Go ahead, Mark.
Okay, Pierre, the IUS PI check is complete. Command source is in MDM. And just for your info, it took us a while to get a clear lock when we are in RF-16K. It finally came in, but it probably took a couple of minutes.
Okay, I understand in RF-16K it took about 2 minutes to get a clear lock.
That's correct.
Okay, Mark, we copy that.
Houston Atlantis.
Go ahead, Norm.
KU antennas deployed with dual motor time.
Hey, Norm, we saw that. Thanks. Atlantis Houston will be handing over to Tidris East in about 5 minutes, and Sunnyvale's working on a problem with their throughput commanding. They should have it repaired by East Tidris, and we'll do that event once we get on East Tidris.
Okay, we copy that, Pierre. Looks like we got some clouds down there.
Well, we had some earlier when we came in here. Atlantis Houston for Mark. Good throughput commanding from Sunnyvale. Your go to press on.
Okay, he's downstairs right now, but we'll pass that along to him.
Roger that.
It's Mission Control Houston, 3 hours, 23 minutes mission elapsed time. Just had a report from Sunnyvale that we had a good check of the PI, the Payload Interrogator, which is a system aboard the orbiter that sends radio signals to Magellan and will be one of the primary command links to the spacecraft, both to Magellan and to IUS. The other system that is used at various times in this deploy timeline is the PDI, the Payload Data Interleaver. Basically, both the PDI and the PI perform the same function. The Payload Interrogator is an RF link, and the Payload Data Interleaver is hardwired. At any rate, both those systems healthy. The checkout just completed of the Payload Interrogator, and all moving briskly and correctly in the timeline for the deploy of Magellan in about 3 hours, 8 minutes. That comes out to just a few minutes after 8 p.m. Central Daylight Time this evening.
Houston Atlantis.
Go ahead.
Okay, we're happy with our stars, and delta angles are there for you to see. If you like, we'll execute the alignment.
Hey, looks good to us. Your go, Dave.
Okay, we executed the alignment at 3 hours, 28 minutes even.
Copy, Dave. 3:28 even.
Okay, Pierre, deselecting IMU 3 and 1 minute warning to AMU data take number 1.
Okay, Ron, we copy. 1 minute till AMU data take number 1.
Okay, Pierre, we're in free drift. This is AMU data take number 1.
Roger that.
Okay, we'll be starting our maneuver to AMU attitude 2 now.
Roger that, Dave.
It's Mission Control Houston, 3 hours, 32 minutes mission elapsed time. Atlantis maneuvering now for the first of 3 attitude match updates. Essentially, that procedure involves maneuvering Atlantis and watching the numbers on the ground as recorded by the Inertial Measurement Unit platform aboard Atlantis, and then comparing those to the inertial references aboard the inertial upper stage to make sure that both of those systems are in sync. The probable use of the data from this technique, from this procedure, would come on flight day 2 to make sure that the inertial reference for IUS Magellan has the highest fidelity possible prior to the deploy. On flight day 1, it's not felt that the IMUs will have degraded to the point where that will be necessary, and so far everything proceeding well toward a deploy in about 2 hours 44 minutes, and at 3 hours 33 minutes, this is Mission Control, Houston.
Houston Atlantis, 1 minute to data take number 2 for AMU.
Hey Dave, we copy, we're ready.
And Houston Atlantis, this is AMU data take number 2, commencing at 3 hours 37 minutes.
Copy, we're on 337.
Okay, we are complete and ready to maneuver to AMU attitude number 3.
Roger that.
It's Mission Control, Houston, at 3 hours 42 minutes mission elapsed time. The 3 AMU data takes have been completed. Those stand for attitude match update. Next major event will be the activation.
1 minute warning to AMU data take number 3.
Atlantis, Houston, we copy.
Correction, 2 AMU data takes have been completed, the third about to begin. Following that, the next major event will be the activation of the data management system recorders aboard Magellan. For those following along in the crew activity plan, on page 3-6 of the CAP in the summary timeline, the deploy listed at 6 hours 18 minutes mission elapsed time. Our best guess at the moment is that that will happen a bit earlier at 6 hours 14 minutes 22 seconds MET. That would put the deploy taking place over the west coast of the United States as Atlantis passes over the Goldstone Vandenberg area, and that'll be coming up in about 2 hours 34 minutes. This is Mission Control, Houston.
Okay, at 43:30 we started the AMU data take number 3. Went to pre-drift.
Understand, 3:43:30, we copy.
Houston Atlantis, we're complete with the AMU data takes and we're ready to start the maneuver. Back to negative ZLV.
Roger that, Dave, you go for that.
It's Mission Control, Houston, at 3 hours 42 minutes mission elapsed time. The 3 AMU data takes have been completed. Those stand for attitude match update. Next major event will be the activation.
1 minute warning to AMU data take number 3.
Atlantis, Houston, we copy.
Correction, 2 AMU data takes have been completed, the third about to begin. Following that, the next major event will be the activation of the data management system recorders aboard Magellan. For those following along in the crew activity plan, on page 3-6 of the CAP in the summary timeline, the deploy listed at 6 hours 18 minutes mission elapsed time. Our best guess at the moment is that that will happen a bit earlier at 6 hours 14 minutes 22 seconds MET. That would put the deploy taking place over the west coast of the United States as Atlantis passes over the Goldstone Vandenberg area, and that'll be coming up in about 2 hours 34 minutes. This is Mission Control, Houston.
Okay, at 43:30 started the AMU data take number 3. Went to pre-drift.
Understand, 343.30, we copy.
Houston Atlantis, we're complete with the AMU data takes, and we're ready to start the maneuver. Back to negative ZLV.
Roger that, Dave, you go for that.
This is Mission Control Houston, about 7.5 minutes remaining in this pass through the Tidris East satellite. We're coming up on a loss of signal. And at about 3 hours 45 minutes into the mission, a lot of squares are being filled. The KU band antenna has passed its self-test, which is good. And per the timeline, the crew has completed the...
Houston, for Dave, could you read us again the angular error you had for the IMU alignment? We missed it.
Okay, stand by a second. And it was a .01.
Copy, .01, thanks.
Meanwhile, the crew has also completed deactivation of the APU steam vent heaters. They have completed all 3 attitude match update data takes, and Commander Walker has asked for and gotten permission from Mission Control to maneuver back to a minus ZLV minus XVV tail forward attitude.
Houston Atlantis.
Go ahead.
KU and tags are activated, no anomalies noted.
Hey, Norm, thanks. We saw that, and INCO's going to power it off for you, and you'll get a message with that.
Okay, we'll be expecting it.
Atlantis, Houston, about 2 minutes till LOS Tidris East. Scheduled Tidris West AOS is at 4 hours 2 minutes MET, but we expect a late AOS due to the attitude. And we also would like to have you leave the APU cooling run just a little longer, and we'll give you a call on that.
Okay, thanks, Pierre. And Pierre, before we lose you, Cryo 02 tank heater sensor check has been completed and no anomalies noted.
Okay, thanks, Rom. We saw that. Atlantis, Houston, with you now through Tidris West.
Atlantis, roger, loud and clear.
Atlantis, Houston, we're shipping you a new orbiter state vector.
Roger, Pierre.
Atlantis, Houston, you have a go for state vector transfer.
Copy, go for state vector transfer.
It's Mission Control Houston, 4 hours 9 minutes mission elapsed time. Sunnyvale flight reports a good state vector transfer from the orbiter Atlantis to the inertial upper stage. Both the ground and the crew still running slightly ahead of the nominal deploy timeline. The deploy is still planned to take place in about 2 hours 7 minutes, or at a mission elapsed time of about 6 hours 14 minutes. Meanwhile, Magellan flight has confirmed that sequence 1 aboard Magellan has been completed. That concluded with the activation of the data management system recorders aboard the spacecraft. Also, to support Magellan, the Mila and Goldstone stations have been released from the Manned Spaceflight Support Network, and they'll be in use for Magellan support into the evening hours. And in another 10 minutes or so, the Guam station will be released for Magellan support.
Atlantis, Houston, you have a go for APU cool-off.
Roger that.
Atlantis, Houston will be shipping you a target state vector shortly.
Houston Atlantis, copy that.
worrying to me at this moment, looking out in the day. What a really clean spacecraft Atlantis was, even right after Ascent, when stuff usually floats around. It was mighty clean in the cockpit, and the bay was mighty clean, and the people that are responsible for that should get a big attaboy.
Okay, Dave, we appreciate that, and we'll make sure they get that word.
Thank you.
I guess you guys are in your meal. I was wondering how Mark was enjoying his first meal. Or has he already eaten several times?
He has a small speech prepared. I'll let you talk to him.
Okay, we're standing by.
Well, Pierre, I'd just like to say that it was one small bite for me, one giant meal for maggot kind.
Okay, Mark, we copy that. Good words. Atlantis, Houston, 1 minute till handover to Teeters East. We'll lose you for about 30 seconds during handover.
Okay, Pierre.
Atlantis, Houston, with you now in the East Teeters.
We copy.
Atlantis, Houston for Mark.
Go ahead.
Okay, Mark, due to the problems you had getting the CIU locked up earlier, we'd like you to perform the IUS PI lock at 5 hours and 20 minutes, vice 5:30. And also, if at any time you start getting some erroneous messages and erroneous data that we believe may be similar to what happened on STS-29, we'd like you to work SSR2, page 1-40 of the Payload Malbook.
Okay, Pierre, copy all that. We'll start PI lock at 5:20.
That's good copy, and I've got the pads ready whenever you guys are done eating.
Give us a minute, Pierre, and we'll be ready.
Okay.
Mission Control Houston, 5 hours, 7 minutes mission elapsed time. That call from Capcom Pierre Thuet up to Mark Lee, mission specialist aboard Atlantis, having to do with the approaching part of the pre-deploy timeline where they will be hooking up the payload interrogator and attempting to establish a lock between that and the inertial upper stage, and that will then become the channel for the sending of commands from the ground through the orbiter's PI to the IUS and into the payload system and the IUS Magellan stack. There was a couple of minute lag earlier in one of the test procedures that they did.
And Atlantis are ready to copy the pad.
Okay, we'll start with the deploy pad. Orbit 6 Alpha. Deploy attitude pitch 275.3. Omicron 270.0. Initiate track 0, slant 05:34:00. Deploy time 0, slant 06:14:22. Deploy window 07:11. Window protect 009.8.
Okay, Pierre, we copy pitch 275.3, Omicron 270.0. Initiate track 5:34:00. Deploy time 6:14:22. Deploy window is 07:11, and window protect Omicron 009.8.
Okay, that's good. Read back. Ready for the maneuver pad when you are.
Go ahead.
Ohms both. TV roll 270. Trim load minus 0.4, minus 5.7, plus 5.7, 204.913, 00 slant 06:29:22.0, peg 7, plus 029er.9er, plus all balls, plus 008.0, maneuver attitude 312.125.285, delta V tote 031.0, 00:16, V goes plus 029er.71, plus all balls, plus 008.66, HA 178, HP plus 160. In the notes, ohms gimbal check, none. RCS interconnect, none. Ohms helium reg test, A closed, B open. IMU deselect, NA. Down mode options, 2 ohms to 1 ohms. Down mode to min-sep delta V 10 feet per second.
Okay, Pierre, readback follows. Ohms both, 270, negative 0.4, negative 5.7, positive 5.7. Weight is 204.913, 00 slant 06:29:22.0, plus 029er.9er, all balls, plus 008.0. Maneuver at 312.125.285. 031.0, 00:16, plus 029er.71, all balls, plus 008.66. 178 by 160, no ohms gimbal check, no RCS interconnect. On the helium reg test, A closed, B open, no IMU deselect, and the down mode 2 ohms to 1 ohms, down mode to minimum SEP delta V of 10 foot per second, over.
That's good readback, Dave. Atlantis Houston will be shipping you the SEP burn targets shortly.
Atlantis, roger.
Mission Control Houston, now about 1 hour remaining before the deploy of Magellan. We're at 5 hours, 14 minutes mission elapsed time. Capcom Pierre threw it just right up to the crew. The deploy attitude and time pad, and also the maneuver pad, which is the orbiter separation maneuver that takes place about 15 minutes after the deploy. As for the deploy itself, still hanging in at 6 hours, 14 minutes, 22 seconds. It may be a couple of seconds before that. Also, the maneuver pad, they will be executing a burn out of both ohms engines about 15 minutes after the deploy. The delta V total is 31 feet per second. That will result in an orbit for Atlantis of 178 by 160 nautical miles. They're currently in 160 nautical mile circular orbit. And the interchange before, a couple of comm funnies came up earlier in the deploy, pre-deploy timeline, and it's a situation that's similar to what was seen on STS-29. What would be the result might be, the controllers feel, some alarms enunciated aboard the flight deck of Atlantis when they did the tilt table activation and put the tilt table up to its first position at 29 degrees. Those alarms, or FDAs, fault detection enunciations, would be based on the some strange signals passing back and forth between the PI, the payload interrogator, and the IUS, simply because They feel there could be a couple of minute lag before the PI was locked on to the communications interface unit or aboard the IUS. It's no problem. It may involve the crew having to work a couple of malfunction procedures, but they would be communications configuration related, and none are related to any safety issues. And so they asked the crew to move that up about 10 minutes in their timeline. It was nominally scheduled to take place, the payload interrogator lock procedure is scheduled to take place about 5 hours, 30 minutes mission elapsed time. They've asked them to move it up at about 10 minutes. That way they, both here in Houston and in California, controllers can get a good look at the data that the crew is seeing as it's happening through TDRS, and be right on top of the situation, be able to offer any advice on exactly which of several malfunction procedures they might use. And it's a situation that is very similar to what we saw on STS-29, and again merely involves lag time in the hard lockup between the payload interrogator aboard Atlantis and the inertial upper stage.
Atlantis, Houston, have a late breaking change to your deploy window.
Okay, we're ready to copy.
Okay, it will now be 7 minutes, 07 seconds.
Okay, we'll update our pads.
It's Mission Control, that's a change of 4 seconds. The window duration read up to the crew earlier was 7 minutes, 11 seconds.
Atlantis, Houston, 4 minutes till TDRS East LOS, although we may lose you early for attitude. We'll pick you up on the west at 5 hours, 39 minutes. And we'd also like you to take the S-band payload control to command.
Okay, Pierre, we got that.
Okay, Dave, and we were wondering if Mark had any trouble getting the CIU to lock up on this last attempt.
I'll let him tell you.
No, Pierre, it was almost immediate this time.
Okay, thanks, Mark. Atlantis, Houston, one last thing. There are no changes to the go, no-go cue card.
Okay, Pierre, go ahead with that.
Dave, there are no changes.
Understand, no changes. Thank you.
Roger that.
It's Mission Control Houston, 5 hours, 30 minutes. Mission elapsed time, about 44 minutes remaining before the deploy of Magellan. Just before we lost signal through TDRS East, Mission Specialist Mark Lee reporting that the lockup between the payload interrogator aboard Atlantis and the communications interface unit aboard the IUS was almost instantaneous, which is good news. During this LOS period, there will be a tag up between the mission managers and mission directors here in Houston and at the Sunnyvale and JPL POC, and they'll be discussing the final go, no-go criteria and assessing the health and vitality of each of the systems as we approach deploy in about 43 minutes. This is Mission Control Houston.
Atlantis, Houston, with you now through TDRS West.
Houston, Atlantis, loud and clear.
Okay, reading you the same.
It's Mission Control Houston, 5 hours, 41 minutes mission elapsed time. We've had acquisition through TDRS West, and during the short loss of signal period between the two satellites, the mission directors held a briefing on one of the internal loops. The inertial upper stage flight director declared the IUS go to support the deploy of Magellan, and Magellan flight director declared Magellan go. The orbiter Atlantis is go, and there are now 32 minutes, 27 seconds remaining before we're prepared to eject Magellan out of the payload bay and send the spacecraft on its way to Venus.
Atlantis, Houston, we lost you there for a minute while you were maneuvering.
Roger, reading your 5 by now.
This is Mission Control, Houston, aboard Atlantis. The payload retention latch is now being released. The next step will be the transfer of internal power to the inertial upper stage. Magellan will also go on IUS power shortly thereafter, and then the tilt table will be raised to 29 degrees elevation. So far, latches 1 and 2 have been released. And we now have the report that all 5 of the payload retention latches have been released. It's Mission Control, 5 hours 47 minutes MET. Sunnyvale has reported the transfer of internal power to the IUS is underway. IUS is going on her batteries. That'll be followed by Magellan batteries going online, and Magellan drawing power also from the inertial upper stage. Thereafter, the tilt table will be raised to 29 degrees. Next step after that, we'll be raising the tilt table to 52 degrees. Currently 25 minutes 54 seconds prior to the deploy of Magellan. Mission Control, Sunnyvale has just confirmed the IUS is on internal power, standing by for the Magellan batteries to be commanded online. Mission Control, Houston, we can now confirm Magellan is drawing power from the inertial upper stage. Next step will be elevating the tilt table, and then Magellan's batteries will be commanded online. Mission Control, Houston, 5 hours, 54 minutes mission elapsed time, and Sunnyvale is now confirming first motion of the tilt table up to the initial position of 29 degrees. That will be followed.
Payloads, we're at 29 degrees on internal power.
Roger that, Mark, thanks.
Mission Control at 5 hours, 54 minutes, 25 seconds mission elapsed time. Mission Specialist Mark Lee radioed down from Atlantis confirming that the tilt table had reached its initial position of 29 degrees and that the inertial upper stage was on internal power. The next step will be to command the Magellan batteries online, and that procedure is underway now. First POC command from JPL just went up a couple of seconds ago.
Atlantis, Houston, you have a go for deploy of the Magellan spacecraft.
Copy, go for deploy, Pierre, and at 29 degrees, everything is really looking good.
Okay, thanks, Mark, we're watching.
Mission Control, Houston, now about 17 minutes remaining before the deploy of Magellan. The crew has just been given a go by Mission Control for deploy of Magellan. At that time, Flight Director Milt Heflin instructed Capcom to give the crew a go and said, Capcom, it's time to let Magellan spread her wings. Magellan's batteries are online. IUS has been transferred to internal power. The tilt table is at 29 degrees. Shortly we'll be going to 52 degrees for the final deploy attitude. This is Mission Control, Houston. IUS Magellan is now a standalone spacecraft, still in the payload bay of Atlantis. At 5 hours 58 minutes, however, umbilical separation between the orbiter and the IUS Magellan stack was confirmed. Now about 14 and a half minutes remaining before the deploy. This is Mission Control at 6 hours even into the flight of Atlantis and Magellan. Sunnyvale is reporting tilt table motion from an elevation of 29 degrees up to 52 degrees, the final deploy elevation. Next major step once the tilt table reaches that attitude will be the deploy itself.
Houston, Atlantis.
Go ahead, Atlantis.
Okay, we're changing the weight on the burn solution to 2049013 for the pad, and then we're going to load them up.
Roger that, and we see the IUS is at 52.7.
Thank you much.
This is Mission Control Houston at 6 hours 4 minutes. Sunnyvale flight confirmed that the inertial upper stage and Magellan aboard the tilt table are now raised to an elevation of 52 degrees in the payload bay of Atlantis. Upcoming now in 9.5 minutes, the deploy of the spacecraft. Magellan weighs nearly 4 tons, stands 21 feet high, and is 15 feet wide, and is perched atop the inertial upper stage, which will provide its initial propulsion on the fall toward the Sun and a rendezvous with Venus. The only bad news we have to report here from Mission Control is that the television we had hoped to obtain through Hawaii on Orbit 5 has been canceled. That was intended to bring us views of the pre-deploy activities aboard Atlantis. Unfortunately, the payload interrogator is on, and one of the flight rules says that when that RF link has been established, we are unable to activate the FM TV system. So we're sorry, we had hoped to see that. We do, however, anticipate seeing some videotape of the deploy following that event. It's now scheduled to come up in about 8 minutes 14 seconds, and following that we'll be standing by for some Magellan deploy videotape. So far, all going very well aboard Atlantis and with both the IUS and Magellan. About 15 minutes after deploy of the spacecraft, the Atlantis will maneuver away from that position so that she will be at a safe distance when the first solid rocket motor ignition takes place on the inertial upper stage that will begin the journey of Magellan. And the burn that Atlantis will execute will be a burn out of both orbital maneuvering system engines, giving a change in velocity of 31 feet per second and result in a orbit for Atlantis about the Earth of 178 by 160 nautical miles. Currently, Atlantis is at 160 nautical miles circular. 6 minutes 45 seconds now before the deploy of Magellan. It's Mission Control Houston, 3.5 minutes now before the deploy of Magellan. All still going very well here in the control center in Houston and at the satellite control facility at Sunnyvale and at the Jet Propulsion Laboratory, where 3 teams of flight controllers are watching their data carefully. No systems anomalies to report at this point in the deploy countdown. The deploy will take place due south of California in direct line of sight of Goldstone, one of the primary 3 antenna stations of the Deep Space Network. Magellan will leave Atlantis within line of sight of Goldstone, which is hardwired to the Jet Propulsion Laboratory. The other 2 antennas at Madrid and Canberra in the Deep Space Network maintain satellite links to the United States and to the control center at the Jet Propulsion Laboratory. Magellan will be the 6th spacecraft the United States has sent to study Venus. The first to arrive there was Mariner 2 in 1962. It measured the temperature of the surface of Venus and determined that there was no magnetic field there. The Soviet Union has sent 15 probes to Venus, including radar mapping missions. Balloons have been let loose in the upper atmosphere, and Venera landers have photographed the surface before heat and pressure ultimately destroyed those probes. In 1967, the U.S. probe Mariner 5 flew by the planet, and in 1973, Mariner 10 returned the first television pictures of Venus. Pioneers 12 and 13, the last planetary probes launched by the United States, took pictures and returned scientific data in 1978. Pioneer 13 released 4 atmospheric entry probes into the upper atmosphere of Venus and returned data from the atmosphere and the surface. It also verified the presence of sulfuric acid in the clouds of the Venusian atmosphere. Mission Control Houston, 25 seconds remaining before the deploy. The Guidance Navigation Control Officer reports good attitude, good rates aboard the Atlantis, which will provide a stable platform for the launch of Magellan.
Magellan is deployed.
Roger that, Atlantis.
This is Mission Control Houston, Commander Dave Walker aboard Atlantis, confirming Magellan is deployed and on the way to Venus. Deploy took place at about 6 hours, 14 minutes, and 20 seconds mission elapsed time. This is Mission Control, all quiet here and on the internal communications loops linking the Mission Control Center with the Jet Propulsion Lab in Sunnyvale. No chatter at this point, which is a good sign. People still watching their data. But all looked very good with the deploy of Magellan at about 6 hours, 14 minutes, 20 seconds mission elapsed time. Atlantis still retaining good lock with the Magellan through its payload interrogator, and that will continue for several nautical miles as the two spacecraft drift apart. And we're now coming up in about 12.5 minutes on the separation burn that Atlantis will shortly execute to move away from Magellan in preparation for the firing of the solid rocket booster aboard the inertial upper stage and the first real beginnings of the trip to Venus, which will take about 15 months. This is Mission Control Houston, now about 4.5 minutes since the deploy of Magellan. Next major event will be the unfurling of the solar arrays aboard the spacecraft. 15 square yards of solar panels will power the Magellan instruments with more than 1,000 watts during the journey to Venus and the ensuing operations there. Meanwhile, Sunnyvale Flight has reported an updated official time for the deploy. He reports the deploy took place at 6 hours, 14 minutes, and 29 seconds mission elapsed time. This is Mission Control. Atlantis now maneuvering to the burn attitude for the separation from the vicinity of Magellan. That will be followed about 50 minutes from now by the ignition of the Star 48B solid rocket motor on the inertial upper stage. That motor will propel Magellan toward Venus. The motor will be used once to place the spacecraft into a trans-Venus injection, and then the casing for that motor will be ejected after it is used. The second part of the propulsion system consists of hydrazine thrusters, which will be used to correct the trajectory, trim the orbit during mapping, and provide attitude control when their reaction wheels used to control the spacecraft's attitude are being slowed down to get rid of excess momentum. Magellan has 24 thruster rockets used for trajectory correction and attitude control. 8 of them have 100 pounds of thrust each. 4 of the thrusters have 5 pounds of thrust each, and 12 have just 0.2 of a pound of thrust. They're clustered in modules on the ends of the outrigger booms that provide extra leverage in moving the spacecraft and save on propellant. The largest rockets are used to control rotation of Magellan during orbit insertion and other major maneuvers. While at Venus, Magellan will be kept in proper attitude relative to the planet by 3 spinning reaction wheels. They function as gyroscopes with 1 wheel for each of the spacecraft's 3 axes, pitch, roll, and yaw. Once in each orbit, they must be despun to get rid of excess momentum, and the smallest thrusters are used to control the attitude of the spacecraft while those wheels are despun.
Houston, Atlantis.
Go ahead, Atlantis.
Okay, Pierre, we watched the solar arrays deploy. They came out real quick. They're all out. We've got the tilt table is currently down at minus 6 degrees. And as you probably recall, we deployed on time.
Roger that, Mark. We copy all that. Good work. And we'll be handing over to Tidris East in about a minute, so we may lose you for a short time.
This is Mission Control. That was Mission Specialist Mark Lee aboard Atlantis, telling the ground that the deploy was very smooth and that the tilt table is now back to its stowed position of elevation of minus 6 degrees. Meanwhile, we're standing by for telemetry confirmation of the deploy and locking of the solar panels on Magellan. Also, Atlantis now in the burn configuration, burn attitude for the separation maneuver, coming up in about 3 minutes, 5 seconds.
Atlantis, Houston, we're with you now through Tidris East.
Okay, we're with you, getting ready for the burn.
Roger that. We're looking over your shoulder.
This is Mission Control. The Propulsion Systems Officer reports Atlantis burning, and the separation burn so far looks good. Both OMS motors fired, and the burn now complete. Propulsion reports.
Houston, Atlantis, configured for throughput commanding at this time.
Roger that, Mark. Thanks. Atlantis, Houston, we'll be off the nose shortly with Tidris, so we may lose you for a little while. Atlantis, Houston, we can confirm for you that the Magellan Sequence 2 is in progress.
Roger, that's great.
This is Mission Control Houston. That call from Mission Control to the crew aboard Atlantis confirms that the second major step in the bringing to life of the Magellan spacecraft is successfully underway. That's Sequence 2. That began with the issuance of discrete command number 2. That command designed to enable the solar panel control and battery and propulsion systems control from the ground. We're now at a mission elapsed time of 6 hours 40 minutes. All still going well aboard both the Atlantis and Magellan. The inertial upper stage, meanwhile, has begun to seek an attitude for thermal control. Shortly, the orbiter will assume a position for viewing an attitude maneuver by the IUS when it goes to a local vertical, local horizontal attitude. The flight dynamics officer calculates that by mission elapsed time of 6 hours 59 minutes, Atlantis and Magellan should be about 13.2 nautical miles apart. That's in another 19 minutes or so. This is Mission Control Houston, 6 hours 44 minutes mission elapsed time. The next television on this mission of STS-30, the Magellan Atlantis mission, will be an unscheduled status briefing with John Grafati, the Magellan project manager. That briefing will begin at briefing will take place at 10:30 p.m. Central Daylight Time, originating from the Building 2 briefing room here at Johnson Space Center. And correction, that won't be the next TV event. The next thing we hope to see will be some views from Atlantis, videotape of the deploy sequence itself. We'll give you a status on that television when it becomes available. Again, a status briefing has been planned with John Grafati, the Magellan project manager, for 10:30 p.m. Central Daylight Time this evening.
Atlantis, Houston, have a switch throw for somebody on panel A12.
Okay, go ahead.
Good evening, Mary. Good to hear you. We noticed when the APU-2 GG bed heater was taken to A auto that we didn't see the heater come online. So what we'd like you to do is take APU, gas generator, fuel pump 2, switch to off, then back to A auto, then to off, and then back to A auto. And then we'll take a look at it and see if the heater comes on.
Off mark. A auto mark. Off mark. A auto mark.
Okay, we'll take a look at it now and see if the heater comes back on. We don't want you to switch to the B heater at this time. Just leave it in A for now.
Okay, we copy that. Thanks.
Atlantis, Houston for Mary.
Go ahead, Houston. We'll relay to Mary.
Okay, or if somebody's up on the flight deck there, we'd like them to check that switch one more time. And we had a situation once before where a switch had a false detent and it felt like it was in the correct position, but in reality it wasn't. We'd like you to just check that APU2, GG bed, fuel pump, heater switch, and just press it up real hard into A auto because we're not seeing any response.
Okay, we've got the Hulk pushing on it, and it's not going anywhere.
Roger that. Atlantis, Houston, we see Magellan sequence 2 is complete.
We copy.
This is Mission Control Houston. We're inside 20 minutes now from the initiation of the burn on the Star 48B motor on the inertial upper stage. The IUS burn will take place at a mission elapsed time of 7 hours 18 minutes.
Go ahead, Dave.
And we're getting repeated sort of intermittent camera overtemps on Spec 76. All our payload bay cameras are turned off, and we still seem to be picking up overtemps.
Okay, Dave, we'll take a look at that. Atlantis, Houston, I've been informed that those camera or Spec 76 comm messages could be caused by a VTR operation. Can you confirm that you're working with that?
Yeah, we are looking at the VTR. Maybe that is it.
Okay, that's what we believe is causing that. Atlantis, Houston, we're pretty sure that that's what's causing those messages. We do have a capability to send a command to inhibit that, but that will also inhibit any real messages coming from your cameras when you turn them on. So it's your call.
No, we'll live with it for a while. Thanks.
Okay, sounds good.
Houston, Atlantis.
This is Mission Control Houston. The Flight Dynamics Officer here in Mission Control reports the distance separating the IUS Magellan stack from Atlantis is now 13.1 nautical miles. Shortly, Atlantis will be going to the window protect attitude in preparation for the burn of the inertial upper stage attached to Magellan. This is Mission Control Houston. At 6 hours 59 minutes mission elapsed time, Atlantis moved outside of a distance separating the two spacecraft. Magellan and Atlantis separated now by more than 13.2 nautical miles. Therefore, control of Magellan has now been transferred to Sunnyvale Flight by Houston Flight Director Milt Heflin. Sunnyvale responded, "Thanks for the ride, Houston," and Magellan concurred.
Atlantis, Houston, have a question on tags for you.
Okay, we're listening.
Okay, Dave, we noticed during activation that the developer had a jam. If you guys haven't already done so, we need you to run MAL 2.8 alpha, page 2-59 of the MAL book.
Okay, hang on a second.
Okay, Pierre, when we activated it, it had the jam light. I advanced it once. The sheet came out, and the jam light went away. Has it subsequently jammed since that time?
Stand by. And Mark, we believe it has jammed since then. Atlantis, Houston, how do you read?
Loud and clear now.
Okay, we'll be dropping in and out. We're getting close to Tedra's handover. We do need you to check that. That should have occurred after you've already advanced the paper. And we'll pick you up on Tedra's west at a time of 7 hours and 17 minutes.
Okay, Pierre, we'll see you there.
Atlantis, Houston, we also have you now through UHF IOS.
Okay, copy that, Pierre.
And we'll have you till 7:11.
This is Mission Control Houston. We're acquiring signal now through the Indian Ocean Station. Telemetry being received from Magellan and IUS, also through Indy. And the orbiter Atlantis currently is at the proper window protect attitude. The position she will maintain throughout the inertial upper stage burn, coming up shortly for the IUS and the Magellan stack.
Atlantis, Houston, 1 minute till LOS, IOS. We'll pick you up on the West Tedra's at 7:17.
Okay, Pierre, thanks a bunch.
This is Mission Control Houston. Inside 5 minutes now remaining before the inertial upper stage solid rocket motor ignition. Magellan flight confirms that an airborne ranging and instrumentation aircraft has been dispatched by the United States to that area over the Indian Ocean where the burn will take place, over which the burn will take place. And we hope to be able to confirm through the services of that aircraft telemetry that would give us some sense of the status of the burn, how it went, and what its duration was. And we'll bring you that information that comes into the control center. This is Mission Control Houston. Sunnyvale flight reports ARIA acquisition of the Magellan IUS stack. ARIA, again, is an acronym standing for Airborne Ranging and Instrumentation Aircraft, and that will be monitoring telemetry from the spacecraft during the IUS burn. This is Mission Control Houston. Sunnyvale flight reports the SRM-1 burn aboard the inertial upper stage began at a mission elapsed time of 7 hours, 14 minutes. We're standing by for the completion of the burn and a status report. Nominally, that burn is scheduled to last for 169 seconds.
Atlantis, Houston, with you now through Tedra's West. And Dave and the rest of you folks, SRM-1 occurred on time and is complete.
That is...
Okay, and while it's still fresh in your minds, we'd like you to try to give us, if possible, an Ascent debris report and the condition of your forward windows if you get a chance for that sometime. Okay, Dave, we copy all that?
Was substantially...
Okay, Dave, we copied all that, thanks. Atlantis, Houston, we have a good stage 1 and 2 SEP and SRM-2 ignition. Roger that.
This is Mission Control Houston. Unofficially, we show the times for the initiation of the first solid rocket motor burn. First stage of the IUS was at 7 hours, 14 minutes mission elapsed time, concluding at 7 hours, 17 minutes MET. Following that, there was a good separation between the first and second stages on the IUS, with SRM-2 ignition beginning at 7 hours, 20 minutes MET. Standing by for confirmation of the end of the second burn.
Atlantis, Houston, SRM-2 complete. Roger that, Dave, and everybody else down here feels the same. Okay, stand by 1 day. Let me check on that. Okay, Dave, you have a go for that.
Houston, Atlantis.
Go ahead, Mary.
It appears after looking with a flashlight that we have a paper jammed pretty far back in tags, and it's going to be delicate, so we'll just wait till we get the two hands on, and that may not be tonight.
Okay, we understand. Atlantis, Houston, Magellan sequence 3 is complete.
Okay, we copy, Pierre.
Atlantis, Houston, have a note for you on your fuel cell purge you're going to do during pre-sleep.
Okay, Pierre, ready to copy the note.
Okay, Dave, due to what we saw on STS-29 with Cryo Tank 3, we'd like you to do the fuel cell purge as soon as you can in pre-sleep. And we want you to use the auto procedure Orbit Ops page 6-7. Once you've completed the purge, we'd like you on panel R1 to take the O2 and H2 tank 3 heaters, A and B, 4 of them to auto. Then the O2, H2 tank 2 heaters, A and B, 4 to off. And the O2, H2 manifold valve, tank 1, 2 switches to close.
Okay, Pierre. Understand you want the fuel cell purge done ASAP in pre-sleep. You want to use the auto procedure. When it's through, we take the O2 and H2 tank 3 A and B heaters, all 4 switches to auto. The same switches on tank 2 go to off. And the O2 manifold switch for tank 1 goes closed. And H2, excuse me, O2 and H2.
That's good copy, Dave. Atlantis, Houston, got a couple more notes for you regarding pre-sleep. When you do your LIO can change out and you take out can number 1 and replace it with can 3, we'd like you to take the can 3's bag and insert can 1 into that bag and seal with gray tape. The rationale here is that that can is not fully saturated and we can use it in a contingency situation later if required.
Okay, Pierre, we'll do that.
Okay, also, no water dump will be required pre-sleep. And can you have someone confirm for us that closeout has been complete?
Okay, Mark confirms closeout's complete. We understand no water dump.
Roger that.
This is Mission Control Houston, 7 hours, 35 minutes mission elapsed time. Great deal has been happening here in the last couple of minutes as housekeeping for the pre-sleep activity gets underway aboard Atlantis. Meanwhile, Magellan is coming to life. Discrete sequences 1 through 3 have been completed. Discrete sequence 4 is now underway. Also, both of the solid rocket motor burns have successfully taken place. Magellan is on the proper path toward Venus, falling toward the sun as we speak. The discretes are commands which begin to switch on various major systems aboard Magellan. These include such commands as venting the propulsion system, turning the S-band transmitter on, firing some of the pyros that control some of the second stage SRM-2 separation procedures. The star scanner will be going on with this discrete 4 series of commands that are now underway. And shortly, as Magellan separates from planet Earth, she will come alive and begin the free fall, 15-month free fall to Venus. Also, we had questions about the Orion aircraft. Those typically are U.S. Air Force aircraft that are configured to take telemetry. They fly out of Vandenberg, and generally the architecture of the aircraft is such that it's either a modified 707, an RC-135, or a modified Lockheed Electra, in this case a Neptune. We're not exactly sure which exact type of aircraft was out over the Indian Ocean to receive the Magellan telemetry during the first solid rocket motor burn. Also, we finally have gotten confirmation that Magellan's solar panels were latched after the deploy. That was one of the confirmations that we never got exactly on time in the checklist for post-deploy, but that has taken place, and Magellan Flight has confirmed the health of the solar panels aboard Magellan.
Atlantis, Houston, the INCO will be shortly, very soon, turning power amp system 1 to off. Atlantis, Houston, one more bit of news on Magellan. We've confirmed spacecraft SEP from the SRM-2.
Pierre, say it again, please.
We've confirmed Magellan separation from stage 2.
That's great.
It's on its way.
You should be able to maneuver yourself to a pretty good party somewhere this evening.
Well, we'll be getting off pretty late, though. I don't know.
Houston, Atlanta.
Go ahead, Dave.
You can have the flight deck TVs if you like for a little while here.
Okay, I understand the flight deck TVs. We'll put that in work.
And the Magellan guys might want to watch.
Okay, we'll alert them. Atlantis, Houston, we got a good picture on board now.
Mission Control Houston, 7 hours, 49 minutes mission elapsed time. We're taking some unscheduled television from the flight deck of Atlantis. Just before the picture signal was lost there momentarily, we saw Mark Lee and Mary Cleve on the aft flight deck. Mark Lee holding a sign that said Venus or Bust. This is Mission Control. Apparently that brief view we saw from the flight deck was seen only over here in the control center. It was a view that came down to us before the picture was entirely locked up. We've lost signal for just a minute, and they're trying to reacquire.
Atlantis, Houston, when you guys do get around working on tags tomorrow or whenever, we'd like you to count how many pages were in the tray before you get to the jam.
I have the answer on that for tags. It was 17 sheets. It jammed on the 18th.
Okay, we copy Mary. 17 sheets. It jammed on the 18th.
Houston, West.
Go ahead.
Okay, Pierre, we've got the stars in the table and we're ready to initiate the align. The delta angles are available for you on spec 21. The angular error is 0.01.
Okay, Ron, we see what we need. You go for the align.
Roger.
This is Mission Control Houston. We've been temporarily unable to lock up the TV that the crew had hoped to send us live from the flight deck. We're also hoping shortly to take some videotape views from Atlantis of the deploy of Magellan and IUS. Meanwhile, the separation of the spacecraft Magellan and the inertial upper stage was confirmed at 7 hours 42 minutes mission elapsed time. According to the flight dynamics here, preliminary estimates show that at 9:30 p.m. local here in Houston, at 9:30 Central Daylight Time this evening, the inertial upper stage Magellan stack was about 3,700 nautical miles in altitude, and 30 minutes later it was predicted to be at 9,300 nautical miles altitude. Rough calculation shows that would give Magellan a velocity in excess of Earth escape at approximately 28,700 nautical miles per hour. Those are very rough numbers, but suffice to say the two solid rocket motor burns did their work. Also, the customer support room here in Houston reports, again, rough estimates that currently Magellan is traveling 6,000 miles per hour relative to the Sun, 25,000 miles per hour relative to the Earth, that it will travel 806 million miles on the way to Venus. When it arrives there, its velocity relative to the Sun will be 86,000 miles per hour, or 25,000 miles per hour relative to Venus. And again, those are rough numbers, but they give some idea of the speeds and distances involved in the epic journey of Magellan. This is Mission Control with a note for our television users. We're taking some hits on the terrestrial circuits between here and the NASA ground terminal at White Sands. The result is, in order to bring in a clean feed of the dump of the videotape showing the Magellan IUS deploy, it will be necessary to interrupt transmission of NASA Select from JSC shortly. Our broadcast will resume at approximately 10:15 p.m. Central Daylight Time. The next transmission viewers see should be non-standard. We hope to resume within about a half an hour and bring our satellite users views of the Magellan IUS deploy. This is Mission Control, Houston.
Atlantis, Houston, have a switch throw for you on panel A12.
Go ahead, yeah.
Okay, we believe that APU-2 GG bed fuel pump heater has the switch is not working in the A auto position. We'd like you to go to B auto now so we can watch it prior to sleep.
Okay, going to B auto.
Atlantis, Houston will be handing over to Tidris East in about minute 30. Pick you up shortly thereafter.
We copy.
Atlantis, Houston with you now through Tidris East.
Atlantis, roger.
Atlantis, Houston, looks like we're all set up for your VTR dump whenever you're ready for it.
Atlantis, roger. Houston, Atlantis, are you getting a good downlink?
That's affirmative, Mark. Looks real good.
Okay, I think it'll only be about another 20 or 30 seconds, and then we'll see the deploy.
Roger that.
This is Mission Control, Houston, at 8 hours 15 minutes mission elapsed time. We're currently taking some videotape replay from Atlantis. Here in Houston, we're seeing this view in color and in its proper field sequential configuration. Satellite TV users around the country will see this version in a few minutes, in about 15 or 20 minutes, we hope, when we have a chance to replay this over the satellite. And we ask your indulgence. Meanwhile, the guidance, navigation, and control experts at Sunnyvale report that their official separation time for the IUS Magellan stack was at a Greenwich Mean Time of 125 days, 02 hours, 27 minutes, and 22 seconds.
And Houston, Atlantis, we followed it with the B camera for just a little while to watch the tilt table. We didn't notice any motion here at all. And then we switched up to the Delta camera, and we followed it till it went up by the forward bulkhead, and then we went back to the B camera. So that's a sequence you'll see.
Roger that, Mark. Looks real good down here.
Houston, Atlantis.
Go ahead, Mark.
Yeah, Pierre, at this point, we're trying to zoom in and out, and the blooming was so bad we couldn't get anything. I can't tell what you guys are seeing right now, but it's not a real good picture on our monitor.
Yeah, it looks like the sun right now.
Okay, that's what I thought. That's what just about the rest of this is. We can go ahead a little ways if you want to see any of the ASC or the closeout, but that's about all we could get.
Do you have anything that shows the solar array deploy?
We caught that. We've got some still photos of it, but we could not pick it up with the cameras.
Okay, we understand. And you can go ahead.
We also got some 16 millimeter of the solar arrays out, and quite a few 70 millimeter shots, and I think they'll all turn out pretty good.
Okay, Mark, then you can go ahead and fast forward the other stuff. And while you're doing that, just some info. The FIDO's figured out that about 15 minutes ago, Magellan was at passing through an altitude of 9,300 miles.
Okay, that's moving right out.
Doesn't take it long.
And Houston, Atlantis, do you want to see the tilt table, or just do you want me to fast forward through this part?
Yeah, that's fair, Mark. You can go ahead and fast forward up to the next sequence.
And Houston and Atlantis, we're setting up for closeout at this time. Our monitors don't show a very good picture. Are you getting a good one?
Yeah, we got a good picture. Atlantis, Houston for Mary.
Go ahead.
Yeah, we were just wondering if Mary was comfortable with the aft bulkhead thermal blanket DTO for tomorrow, and we were wondering if she needed anything else to help support that. We could turn the planning shift on if she needed anything for that.
No, Pierre, we got some good pictures down there, and our initial look at it is we have a little bit of droop on the left-hand side as you're looking aft, but overall it doesn't look like it moved very much.
Okay, thanks, Mark.
And Houston, Atlantis, we had to turn the monitors off so we could do our COAS. If when we get to the end of the tape, if you want to let us know, and we'll stop it.
Okay, Mark, thanks. We'll do that. Atlantis, Houston, looks like the tape's complete. Thanks for the playback.
Okay, Pierre, we didn't quite copy. Could you say again?
Yeah, it looks like the VTR tape has completed, and thanks for the playback.
Roger.
This is Mission Control, Houston. NASA Select is now originating again from Johnson Space Center. We've just concluded taking a video tape from the spacecraft Atlantis showing us the deploy of Magellan. For our satellite users, those of you around the country who saw that in a flickering black and white television picture, you'll just very shortly see it in color. We will be replaying that just as soon as we've got the tape rewound. And following that, we will bring you a briefing with John Graffiti of the Magellan Project. This will probably mean a 5 to 10 minute delay of the Graffiti briefing, and as soon as we have those times, we'll bring them to you. This is Mission Control, Houston.
Okay, Dave, we copy Delta bias 0.06 on the second one. Atlantis, Houston, 2.5 minutes till LOS Tidris East. We'll pick you up on the west at 8:54.
Atlantis, roger.
And we're shipping you a new orbiter state vector also.
Roger that.
Atlantis, Houston, with you now through Tidris West.
Copy, Pierre.
Atlantis, Houston will be shipping you some compensations for IMU 1 Z-axis, 2 Z-axis, and 3 X-axis.
Atlantis copies.
Atlantis, Houston, regarding your APU-2 GG bed fuel pump heater, we see in the position 2 auto that all the heaters are working properly, so that looks good, and we believe the A auto has failed.
Roger, copy. We'll consider A auto failed and B auto working fine.
That's a good copy. Atlantis, Houston. Atlantis, Houston.
Go ahead, Pierre.
Okay, we're going to say a good night to you here if we can. Let you get ready for bed. A couple things. First of all, Magellan's still looking real good. Super job today working that. We've got a teleprinter trage message we're working on that we're going to get to you real soon to check out the teleprinter before you go to sleep. We'll let you know when we send it up, and we'd like to get some feedback on its quality.
Okay.
And we don't have anything else for you tonight. Hopefully we won't have to bother you again except for the teleprinter before you go to sleep.
Okay, Pierre, please pass on our congratulations to the Magellan team, and thanks everyone down the Boca for all the help today. Great job. And please pass on our thanks as well to the KSC launch team for a great effort.
Okay, we copy all that. We'll make sure that happens. And if we don't talk to you again, you'll have Ken and Steve will be watching over you during your sleep.
Okay, Pierre, nice work.
Houston, Atlantis.
Go ahead.
Yeah, we're looking at the pre-sleep activities, and we're wondering whether KU band antenna cable positioning is required.
Okay, I believe it is, but let me double check.
This is Mission Control. Momentary loss of signal with handover between the two TDRS satellites.
Atlantis, Houston, we caught you in handover there. We're on TDRS East now, and yes, we need you to do the antenna cable positioning for the KU band.
Pierre, you're a little broken. Will you say again, please?
We do need you to do the KU band antenna cable positioning.
I understand you do want us to do it. It's in work.
Hey, that's a firm. And be advised, on the West TDRS, we were losing you for a while there. We're not sure why. We had some intermittent dropouts of uplink and data.
Okay, we copy.
This is Mission Control Houston, 10 hours, 1 minute mission elapsed time. We've gone ahead due to a dearth of interest around the NASA News Centers and canceled the change of shift briefing with off-going Orbit 2 Flight Director Milt Heflin. Again, that briefing, which had been scheduled to take place at 12:30 a.m. Central Daylight Time, has been canceled. Meanwhile, here in the control center, the briefing between the
Atlantis, Houston, you can check your teleprinter now. We believe we've sent you the trajectory message.
Okay, we'll check.
And Dave, if you could give us some feedback on the quality of it, we'd appreciate it.
Okay, just a second.
This is Mission Control. While we stand by awaiting the word from the crew on the quality of the first teleprinter uplink of the day. The handover briefing is underway here in the control center between the Orbit 2 and planning teams. All pretty quiet. Virtually no major systems anomalies of any sort to report. Atlantis is very clean. In that last report, the Magellan was very clean, as that spacecraft began a 15-month journey to Venus. Crew sleep period will begin in about 26 minutes. And a reminder again, we have canceled the change of shift briefing with off-going Flight Director Milt Heflin at 10 hours, 4 minutes mission elapsed time. This is Mission Control Houston.
Atlantis.
Go ahead.
Okay, we got the teleprinter here. And it all came through pretty well. It looks like the teleprinter itself is not inking as well as it should at the top of each letter, so you have to do a little interpretation sometimes, but it's legible.
Okay, we copy,
Just
Dave.
like a
Thanks.
bad typewriter.
Understand bad typewriter.
Yeah, but it's, I used to own one like it. You can still read what it says.
Okay, thanks.
And there was nothing garbled. Everything has come through as transmitted, it looks like.
Okay, sounds good. They'll be planning on using that in the morning then to get your morning mail.
Okay, thanks a bunch.
Have a good night's sleep.
Thank you, and thanks again to everybody, and to those of you who watch us through the night.
Roger that.
Mission Control, that report from Commander Dave Walker concerning the quality of the first of the mission's teleprinter messages uplinked to Atlantis, and he reported that the quality is pretty good. A little bit like a bad typewriter, he said, in that he doesn't think the ink is flowing quite as well as it might be on the top of all of the letters. The use of the teleprinter caused the need for the use of the teleprinter caused by the failure of the tags earlier in the day. The tags is the text and graphics system. There was a paper jam in it. Clearing a paper jam is a time-consuming and somewhat complex process, and the crew asked if they might be given until tomorrow to go ahead and do that procedure to see if they can clear it up, and that we didn't really get around to looking at it until after the deploy of Magellan, and by then it had been a long day. And that almost sums up all the anomalies aboard the Atlantis. At 10 hours, 8 minutes mission elapsed time, this is Mission Control, Houston.
This is Mission Control at 11 hours into the flight of Atlantis on shuttle mission STS-30. The crew of Atlantis has officially been put to bed for 30 minutes now, not to be awakened for another 7 hours and 30 minutes. Approximately 8:17 a.m. Central Daylight Time. Here in the flight control room, planning shift flight controllers beginning to assemble flight plan updates for flight day 2, and already putting the finishing touches on the morning mail for the crew. A very quiet, uneventful planning shift ahead of us. On board, the crew is resting comfortably with a cabin temperature of 78.4 degrees Fahrenheit, the 40% cabin humidity level. Atlantis orbiting right now at a orbit of 178.4 nautical mile apogee and 159.3 nautical mile perigee. Orbital period is 1 hour 30 minutes and 57 seconds. Atlantis currently in a slightly less than circular orbit due to the separation burn using Ohm's engines following the Magellan deploy. Atlantis ascended to a 160 by 160 nautical mile circular orbit after a picture-perfect ascent and 2 nominal Ohm's burns earlier in flight day 1. And after the successful deploy of the Magellan IUS combination on time at mission elapsed time 6 hours and 14 minutes, the spacecraft was burned in the opposite direction of Magellan in order to provide separation and protection from the IUS first and second stage burns. After deploy, Magellan's arrays were deployed and confirmed by the crew. 2 good IUS burns accomplished, and Magellan is now separated from the IUS and has escaped orbit around the Earth and is on its way to Venus for a rendezvous some 15 months from now. The MPOC, or Payload Operations Control Center at the Jet Propulsion Lab in Pasadena, currently tracking Magellan on its way to Venus using the 3 ground stations of the Deep Space Network. We do expect to get some update on the tracking of that Venus probe later on in the planning shift. Right now, no major schedule changes in work for Flight Day 2. After a wake up at mission elapsed time 18 hours and 30 minutes, the first chore on the agenda for the Atlantis crew is a maneuver to a proper attitude for aligning the inertial measurement units on board. In addition to that, there'll be an attitude maneuver to follow in order to optimize tracking a data relay satellite line of sight, followed by a day full of data takes and observations with various secondary payloads, including the fluid experiment apparatus, the mesoscale lightning experiment, and the Amos optical sighting experiment. An Amos data take scheduled for orbit 19 in conjunction with an RCS burn. On orbit 19, as the orbiter Atlantis crosses over the Maui site, ground-based electro-optical sensors will collect imagery and signature data of the orbiter, and will study plume phenomena as the crew of Atlantis conducts an RCS burn. Flight controllers working with customer support room personnel and weather forecasters to determine optimum opportunities for mesoscale lightning experiment television data takes for Flight Day 2. Those data takes using the onboard orbiter CCTV system. They're watching for nighttime passes in conjunction with significant lightning and electrical storm activity below. That activity will be recorded on the onboard CCTV video tape recorder. Some of that subsequently dumped to the ground, and some of it seen live on downlink television. The FEA, or Fluids Experiment Apparatus experiment, scheduled for activation very early after the post-sleep activity in the morning at approximately 21 hours and 30 minutes mission elapsed time. The Fluids Experiment Apparatus consists of a materials processing container and 4 Pyrex sample ampules containing indium, and a heat transport device for controlled melting and recrystallizing of the samples. FEA, in short, is a crystal growth system, which, using the microgravity of spaceflight, enhances the effects of floating zone materials processing. Once the FEA is activated, for each sample operation, the crew will set the heater in the FEA apparatus for various float zone size and translation rates, and then periodically collect 8mm video tape using an 8mm camcorder on board. As the movable heater in the FEA apparatus moves along the ampule, the zone of the solid material under the heater will melt, or is expected to melt. When the heater translates, the melted material cools then and forms a continuous crystal inside the ampule. The first 2 runs scheduled for Flight Day 2 for 2 hours each will demonstrate the melted zone stability, and the last 3 runs, which will run for 16 hours each, actually create the larger crystals. Again, a very quiet planning shift in store for the rest of the evening. Most of the morning mail messages are already well in work. Those messages will be teleprinted to the crew. Our preliminary experiences with tags on flight day 1, that is the text and graphics system, has showed some minor problems with paper jamming in the apparatus on board. As that problem developed late in flight day 1, crew opted to wait until flight day 2 to begin in-flight maintenance on that. Procedures are currently being prepared in a message for uplink to the crew. Current plan is to initiate uplink of the morning messages about 30 minutes prior to crew wake up. So when they do get up, the messages will be there for them, ready for review. Atlantis now on the final leg of orbit 8. Currently at an altitude of 161.9 nautical miles. Current orbital parameters show apogee of 177.9 nautical miles and a perigee of 159.4 nautical miles. Again, the crew resting comfortably, nearing an hour into their sleep period, with a cabin temperature of 78.1 degrees Fahrenheit and a relatively comfortable cabin humidity level of 41.2%. Currently 11 hours and 13 minutes into the flight of Atlantis on shuttle mission STS-30. This is Mission Control. This is Mission Control Houston at mission elapsed time 12 hours. Flight controllers just losing data as the orbiter Atlantis crosses out of the range of the tracking and data relay satellite east. 1/2 of a flight day into shuttle mission STS-30. The crew of Atlantis is sleeping and sleeping comfortably, and a cabin temperature of 76.6 degrees Fahrenheit. Cabin humidity of 42.4%. Atlantis currently at an orbital altitude of 177 nautical miles, very close to orbital apogee of 178.3 nautical miles. Current orbital perigee is 158.6 nautical miles. The orbital period, once around, is 1 hour, 30 minutes, and 53 seconds. Not a whole lot going on in the flight control room this evening. A lot of discussion over strategies and activation of FEA or fluid experiment apparatus ampule sampling for flight day 2. Due to the removal of ampule 2 prior to liftoff, the strategy for sampling sequences has been adjusted. A message detailing the strategy for FEA sampling on flight day 2 currently in review here in the flight control room. That message, along with other minor flight plan updates and emergency deorbit opportunity tables and such, are scheduled to be teleprinted to the crew some 30 minutes prior to crew wake. Crew wake currently scheduled for 18 hours and 30 minutes mission elapsed time, corresponding to 8:17 a.m. Central Daylight Savings Time. Crew of Atlantis currently in their sleep period after a well-deserved sleep period after a long day, beginning with a picture-perfect liftoff and ascent beginning at 2:47 p.m. Eastern Daylight Time. carrying, after 2 ohms burns, carrying Atlantis to 160 nautical mile circular orbit. At 6 hours and 14 minutes after liftoff, crew of Atlantis successfully deployed the Magellan Venus probe. Some minutes later, witnessing and photographing the deployment of Magellan solar panels. Some hour after Magellan deployment, the first stage of the inertial upper stage, SRM-1, burned for approximately 3 minutes, followed 2 minutes later by the second stage burn. That burn duration approximately 2 minutes. Shortly after the second stage burn was completed, the Magellan separated from the inertial upper stage and is currently on its way to Venus. The initial command sequence is commanded to Magellan from the MPOC at JPL, reported to be very successful. Magellan's Earth to Venus trajectory, actually an orbital path around the Sun from which it will encounter Venus some 15 months from now. There are no science experiments planned for this 15-month period, but there will be periodic checks on the health of the spacecraft and its instruments. There will be 3 planned trajectory correction maneuvers between now and the time that Magellan encounters the planet Venus. The first one scheduled for some 2 weeks after launch to correct any errors that may have resulted from the upper stage burn. The second correction maneuver would be nearly a year from now, about 345 days after the first trajectory correction maneuver, to simply refine the trajectory to the extent necessary. And the last one would come some 17 days prior to reaching Venus orbit to ensure correct arrival conditions. Each time one of these trajectory correction maneuvers are done, the parameters of that maneuver would be based on radio tracking data provided by the Deep Space Network. The Deep Space Network, or DSN, is a worldwide system for navigating, tracking, and communicating with spacecraft exploring the solar system. The network of radio telescopes at 3 locations around the world is managed for NASA by the Jet Propulsion Lab. The antennas transmit instructions and receive data from the spacecraft and are located in the California desert at Goldstone, near Madrid, Spain, and near Canberra, Australia. Once Magellan reaches orbit around Venus, some orbit trim maneuvers may be needed. The first one would be performed about 5 days after the spacecraft is placed in orbit. That will be to correct the altitude at its closest approach to Venus, about 155 miles from the surface. Another may be performed about 7 days later to ensure its orbit period of 3 hours and 9 minutes. In orbit around Venus, Magellan will map the surface of Venus using radar. The planet's thick cloud cover prevents the use of optical photography, but radar can see through those clouds. The spacecraft's synthetic aperture radar will make high-resolution images by operating as though it had an antenna several hundreds of yards long. The antenna is actually 12 feet across, and it can do this by using computer processing on Earth to simulate a large antenna on the spacecraft. Again, Magellan well on its way, currently beginning its long bend around the Sun for its date with Venus some 15 months from now. We do expect to hear some updates later in the evening from the folks at the MPOC at JPL who are tracking the Magellan via the Deep Space Network. At last check, all systems were working exceptionally well on Magellan. Magellan energy and trajectory all nominal. Since then, we've put the crew of Atlantis to bed at about 10 hours and 30 minutes mission elapsed time. Not due to be awakened for 8 hours since then at 18 hours 30 minutes mission elapsed time, or roughly 8:17 a.m. Central Daylight Savings Time. Flight day 1 was a particularly clean day for Atlantis and crew as far as orbiter systems operations goes. 2 minor anomalies recorded that will not require further action and will have no impact on the flight. There was a failure of a forward RCS jet, which has simply been deselected from available RCS jets for orbital maneuvering and re-entry. Several redundant jets available to use in place of that failed jet. So that jet has simply been taken out of service and will represent no impact to continuing the flight. The other minor anomaly was the apparent failure of a APU fuel pump heater A. The solution to that was simply to switch to the B heater. Temperatures are looking very good. Hypothesis on the failure of, or apparent failure of heater A is that there is some intermittent problem with the switch mechanism on that heater. But the redundant heater B operating well. Heater A simply taken out of service and no impact to the flight. With no action required on those 2 anomalies, again, the task facing the planning team here in the flight control room is simply to refine and prepare the flight plan, the timeline for flight day 2, and prepare it in a number of teleprinter messages to be uplinked to the crew some 30 minutes prior to wake. The agenda for flight day 2 starts with an orbiter attitude maneuver to support the alignment of the orbiter's inertial measurement units, followed by a day full of fluid experiments apparatus data takes, some mesoscale lightning experiment television and still photograph data takes, and on orbit 19 we're looking at an Air Force Maui optical site calibration test, or AMOS. There's no flight hardware on board to support the AMOS test. In fact, the orbiter itself acts as a subject for ground sensor operations. The intent of the AMOS test is to allow ground-based electro-optical sensors to collect imagery and signature data of the orbiter under controlled conditions. And in order to allow the study of plume phenomena, the crew of Atlantis will execute an RCS burn as it crosses over the AMOS site on orbit 19. In addition to that, small number of medical DSOs, or medical investigations, to be conducted individually. Crew will take turns at the treadmill and exercising on orbit. One of the messages going up to the crew will include some in-flight maintenance procedures for unjamming a jammed text and graphics systems apparatus, which is located in the middeck of the orbiter. in a 20-page test sequence. Somewhere around page 17 or 18, a page jammed in the system, and as that occurred late in the flight day and was beginning to infringe on crew sleep, crew opted to attack that first thing in the morning rather than work it prior to sleep. Tag's still in the validation mode, not considered an operational component as of yet. Still interested in obtaining quite a bit of experience and data with the tag system before considering it a given operational instrument. Again, Atlantis currently in a 178 by 160 nautical mile orbit. The present altitude 168.2 nautical miles. Atlantis beginning the descending node of orbit 9. And just crossing over the coast of Eastern Asia. At 12 hours and 16 minutes into shuttle mission STS-30, this is Mission Control. This is Mission Control Houston at mission elapsed time 12 hours and 30 minutes. Magellan Flight Director at the MPOC in Pasadena, California, has just reported to the flight control team that based on telemetry via the Deep Space Network, they confirm that those trajectory numbers are extremely close to specified trajectory numbers. In fact, they report that the final separation attitude of Magellan, as it began its long trip to Venus, was at or less than half a degree from what they expected. So they're well on course, confirmed moving in the right direction, and proceeding towards the first of 3 trajectory correction commands on May 21st. Magellan Flight Director reporting that the folks out at Pasadena are very happy. This is Mission Control Houston at mission elapsed time 13 hours and 10 minutes. Now approaching 3 hours into the crew sleep period. The orbiter Atlantis on the beginning the upward node of orbit 10, just off the coast of South America. Currently orbiting at an altitude of 176.9 nautical miles. As the crew sleeps, the Magellan POC at JPL in Pasadena, California, continuing to monitor the progress of the Magellan Venus Mapper as it begins its journey around the sun to make its date with Venus some 15 months from now. Magellan Flight Director recently reporting to Flight Control Team here in Houston that the trajectory numbers provided through the Deep Space Networks show that Magellan is extremely close to specified trajectory numbers. In fact, the separation attitude on record at the point at which the Magellan separated from the inertial upper stage was at or less than half a degree from specifications. Needless to say, the Magellan folks are very happy with these numbers. The next significant event along the way is a trajectory correction, which is nominally scheduled for May 21st. Again, all systems aboard Magellan operating very well, as is the situation with the Space Shuttle Atlantis right now. Flight controllers not chasing any orbiter systems issues at this time. Somewhat leisurely looking over the final revisions to messages which will be teleprinted to the crew some 30 minutes prior to crew wake. Messages consisting of minor flight plan revisions, a emergency and contingency deorbit opportunities table, and some minor payload procedures revisions for in support of the fluid experiment apparatus. Comfort factors inside the crew cabin still show a very comfortable environment at 75 degrees Fahrenheit and about 41 to 42% cabin humidity. Again, approaching the equator and the beginning of orbit 10. 13 hours and 13 minutes into shuttle mission STS-30. This is Mission Control. This is Mission Control Houston at mission elapsed time 14 hours and 10 minutes. Now that we've reacquired the services of our SATCOM F2R transponder, we can bring orbiter television in from NGT in New Mexico. And the instrumentation and communications officer here in the flight control room looking at possibly firing up the orbiter cameras and bringing down some payload bay camera views. This is Mission Control Houston. There's nothing wrong with your set. We're looking at live television from the payload bay cameras of the orbiter Atlantis. Atlantis currently on the descending node of orbit 10 over the South Pacific Ocean. About midway through the nighttime part of that orbit. The camera is being controlled by the instrumentation and communications officer here in the flight control room on the planning shift. Those cameras will be pointed earthward, looking for any possible thunderstorm activity in support of the MLE experiment. The mesoscale lightning experiment, or MLE, makes special use of the standard orbiter payload bay cameras to look at the Earth and record large-scale lightning in efforts to gain a better understanding of the characteristics of large-scale lightning. Usually electrical activity on the in the atmosphere shows up at night as short localized bursts of light. Again, this live signal from the orbiter CCTV system being acquired through the Tracking and Data Relay Satellite West via its KU band channel. This is Mission Control Houston. We're standing by for another opportunity to take some downlink television from the payload bay cameras of the orbiter Atlantis. Atlantis just having crossed the terminator from dark to light over the central continent of South America. This is Mission Control, finally locking up on a signal from the orbiter Atlantis. Currently taking television at the control of the instrumentation and communications officer here in the flight control room, looking at camera Bravo on the aft side, or the aft end of the payload bay on the port side. Camera now beginning to pan left and tilt up, bringing the airborne support equipment and tilt table into view. This is Mission Control at mission elapsed time 14 hours and 46 minutes. We're taking live television from the payload bay cameras of the Shuttle Atlantis as Atlantis crosses the coast of Brazil and moves out over the Atlantic Ocean. Looking at quite a bit of cloud cover from current orbiter altitude of 177.9 nautical miles. Cameras under the control of INCO, or the Instrumentation and Communications Officer, here in the flight control room. On board Atlantis, 5-person crew, well into their sleep period, not to be awakened for another 3.5 hours. Planning flight controllers currently conducting final review of a small number of messages being prepared for uplink to the crew just prior to crew wake. Those messages consisting of minor flight plan revisions, summary of flight day 2 deorbit opportunity tables, and minor changes to payload operations procedures. This is Mission Control Houston at mission elapsed time 15 hours and 16 minutes. Atlantis has just passed out of range of the Tracking and Data Relay Satellite East due to acquire signal through TDRS West in about 2.5 minutes. We're currently just over 3 hours from crew wake and the start of flight day 2. Atlantis currently at an altitude of 168.4 nautical miles in a 178 by 160 nautical mile orbit. Really nothing to report at this time. All orbiter systems performing very well. The orbiter is still very clean, as it was on flight day 1. Flight controllers on the planning shift here in the control center beginning to complete their review of the morning mail, consisting of several minor flight plan revision messages and the deorbit opportunity tables for flight day 2, as well as some minor revisions to payload operations procedures related to the FEA, or Fluid Experiments Apparatus. There were a very small number of anomalies or systems problems on flight day 1, none of which have prompted action by the planning team or crew. A failed reaction control system jet is easily absorbed by the redundant system of RCS jets. There was no action and no impact on the flight by that failure. The failure of an APU gas generator, or catalytic converter heater, is not going to impact the flight either. That redundant set has been selected to the B side. Heater B is working very well. Temperatures in the catalytic bed, fuel pump and fuel lines of APU number 2, all looking nominal. When the APUs are shut off and taken out of service during the on-orbit phase of the mission, a certain range of temperature is necessary in order for effective catalytic reaction in the gas generator at APU startup. That heater B, again, working well to support that required temperature range in the components of APU 2. Another anomaly encountered on flight day 1 in the right orbital maneuvering system. Right ohms fuel quantity total quantity gauge failed. There was no impact to entry operations due to that failure. The crew can adequately observe and quantify fuel quantity in the right ohms using the aft quantity gauge during entry procedures. So while we'll not busy the crew with a lot of orbiter systems maintenance and support, they will be busy with secondary payloads. Beginning shortly after the morning's IMU alignments and COAS calibrations, the crew will begin a day-long effort to observe and document the development of FEA Sample 1. Also included in the morning messages a number of targets of opportunity for mesoscale lightning experiment data takes. Those data takes involving onboard recording of video acquired via the Payload Bay color cameras, as well as still photography acquired by the crew from within the cabin. There are plans to support 2 AMOS data takes, orbiter itself serving as a target for optical testing from the island of Maui in the Hawaiian Islands on orbit 19 and orbit 22. Atlantis will conduct RCS burns for use in plume signature testing. Again, flight controllers finishing up review of the morning mail with intentions to uplink that in about 2.5 hours, and planning to wake the crew in about 3 hours. Atlantis now on the descending node of orbit 11, an altitude of 163.6 nautical miles, an orbital period of 1 hour, 30 minutes, and 54 seconds. A mission elapsed time 15 hours, 23 minutes. This is Mission Control. This is Mission Control. At mission elapsed time 15 hours and 42 minutes. The orbiter Atlantis on the descending node of orbit 11 over the South Pacific. We're anticipating possible unscheduled downlink shuttle television, again by the control of the instrumentation and communications officer here in the flight control room, controlling those cameras in the payload bay aboard the orbiter. Orbiter currently on the dark side of the Earth. ENCO will be looking for possible lightning storm activity in support of MLE data takes. This is Mission Control, currently receiving a live downlink television from the payload bay cameras of the Shuttle Atlantis. Atlantis orbiting above the Earth at 162.7 nautical miles. This particular camera looking earthward, searching for any possible electrical activity in the atmosphere in support of the mesoscale lightning experiment. This is Mission Control Houston at 15 hours and 58 minutes into the mission. Currently taking live television from Atlantis' payload bay cameras. The short, fairly isolated flashes of light you see in the frame is electrical activity and thunderstorm below. Atlantis orbiting at 170.7 nautical miles over the South Pacific. Payload bay cameras under the control of the instrumentation and communications officer here in the flight control room. ENCO has proven successful in his search for our first mesoscale lightning experiment data. This is Mission Control Houston at mission elapsed time 16 hours and 12 minutes. Currently taking live television from the payload bay cameras of the orbiter Atlantis as Atlantis crosses the terminator from darkness to light. We have the rare privilege of watching sunlight bathe the Earth in the early part of the morning over the western coast of South America. This is Mission Control Houston at mission elapsed time 16 hours and 24 minutes. Shuttle Atlantis currently beginning its ascending node on orbit 12. Currently orbiting at an altitude of 178.4 nautical miles. We're now about 2 hours away from waking up the crew of Atlantis to begin flight day 2. It's been a fairly quiet, uneventful planning shift so far. The planning team's effort so far has consisted of preparation and review of a small number of messages which will be teleprinted to the crew about 30 minutes prior to crew wake. Those messages include minor flight plan timeline revisions, a deorbit opportunities table, and some minor payload operations procedural changes. Those procedural changes specifically revisions to the FEA or Fluid Experiments Apparatus procedures due to the deletion of ampule number 2 from the FEA package prior to launch. A backup sample management plan has been devised and prepared in a message to the crew. That first FEA sample data take, scheduled for mission elapsed time 22 hours and 15 minutes, with FEA sample 1, will begin 16 hours of FEA status testing and observation and photo documentation. Those status reports and documentation scheduled to take place every 30 minutes during the 16-hour sample run. Early morning activities on the part of the Atlantis crew will involve shortly after wake-up maneuvering the orbiter to the proper attitude for alignment of the inertial measurement units on the vehicle. Shortly thereafter, a DTO to evaluate the possibility of using the heads-up display in the forward flight deck and the cockpit windows of the crew cabin as an option to the COAS mechanism used for COAS alignment. The possibilities of using the HUD for star sighting and alignment instead of the CAL is instead of the COAS is what that particular DTO is going to look at. That investigation again scheduled to occur right after the IMU alignment. A number of MLE targets of opportunities are being included in the teleprinter message to the crew. Those opportunities over the South Pacific in periods of dark and over Southeast Asia in periods of dark, looking for electrical storm activity in the atmosphere below. Again, the crew will be recording any activity they might find on onboard videotape as well as 35mm photography. There are two Amos data takes scheduled, one on orbit 19 and one on orbit 22, both in conjunction with RCS burns to be performed by Atlantis crew as they cross over the Maui optical tracking station. For those two Amos data takes, there is no flight hardware on board to be used in support of the Amos data takes. The orbiter itself acts as a subject for ground sensor operations at the Air Force Maui Optical Site. The intent is to provide for optical site calibration tests by allowing ground-based electro-optical sensors to collect imagery and signature data of the orbiter, and to allow the study of plume phenomena as the orbiter fires its reaction control system thrusters while passing over the island of Maui. Currently taking live downlink television from the payload bay cameras of Atlantis. The instrumentation and communications officer here in the flight control room operating those cameras. Atlantis just having crossed the west coast of the continent of Africa. These spectacular live downlink television scenes taken high above the African continent from an altitude of 176.8 nautical miles to be exact, provided by the planning shift INCO, commanding those cameras from the ground. This is Mission Control, currently taking live color television from the orbiter Atlantis. This particular view coming from orbiter camera B, located on the aft bulkhead on the port side, looking forward above the crew cabin. The orbiter currently in a nose north attitude, therefore this view looking northward up the globe beyond the northern part of the African continent. This live view from the payload bay camera of the orbiter Atlantis as Atlantis crosses along the north coast of Libya, along the Mediterranean Sea. Now just about to leave the frame Benghazi. Again, to properly orient viewers, the top part of the frame is actually the southern part of the terrain that we're looking at. As you move to the bottom of the frame of the picture and around the globe, you would be looking or moving in a northerly direction. This particular camera located on the aft port location in the payload bay, looking forward across the top of the crew cabin. The orbiter currently in a nose north attitude, thereby the camera looking north along the globe. Atlantis orbiting high above the North African coast at 173.7 nautical miles. Currently passing over the northern border of Egypt along the Mediterranean Sea. Atlantis just having crossed over the Sinai Peninsula, now over Saudi Arabia on orbit 12, bringing us live downlink television from the orbiter payload bay cameras. Still about an hour and 45 minutes away from crew wake up. These television scenes are brought to you by the instrumentation and communications officer here in the flight control room, controlling those CCTV systems on board from his console here in the control center. And just coming into your frame on the left side, the northern end of the Persian Gulf. Again, just to properly orient the view, this camera looking northward up the globe, north being at the bottom part of the frame and south at the top. The orbiter now orbiting at approximately 170 nautical miles, just having rounded the peak of the ascending node of orbit 12. Currently in view around the northern end of the Persian Gulf, in the upper right-hand portion of your frame, the country of Kuwait, and on the left-hand lower portion of your frame, the country of Iran. Looking directly below Atlantis, we see the western coast of Iran along the Persian Gulf. Coming into view now, the Gulf of Oman and the Strait of Hormuz. And we've just lost line of sight with the tracking and data relay satellite and our KU band antenna aboard Atlantis. Just about to pass out of range altogether of the tracking and data relay satellite east. And we've lost signal through the tracking and data relay satellite east. Expect to acquire signal again through Tudor's West in about 8 minutes. Currently an hour and 40 minutes away from waking the crew of Atlantis. In about 1 hour or 30 to 40 minutes prior to crew wake, controllers here in Houston will be uplinking the morning teleprinter messages. Again, it has been a relatively quiet planning shift here in the Flight Control Center. The planning team's efforts principally in developing and reviewing a small number of teleprinter messages, including flight plan revisions, deorbit opportunities table, and very minor payload operations procedure changes. After a very highly successful Flight Day 1, which began at 2:47 p.m. Eastern Daylight Savings Time with picture-perfect liftoff, leading to, after 2 ohms burns, a 160 by 160 nautical mile circular orbit. Crew of Atlantis successfully deployed the Magellan Venus probe at mission elapsed time 6 hours and 14 minutes. Some minutes later, crew reported visually sighting Magellan solar panels deploying, and were able to document that with onboard photographic equipment. Some hour or so later, first stage of the inertial upper stage burned for about 3 minutes, followed shortly thereafter by a second stage burn for about 2 minutes. And following a successful dual stage burn, the Magellan separated from the IUS and is currently on its way. Earlier in the planning shift, about 2:15 a.m. Central Daylight Time, the Magellan flight director from the MPOC at the Jet Propulsion Lab in Pasadena, California, reported that trajectory numbers provided by the Deep Space Network currently tracking the Magellan probe are extremely close to the specified trajectory numbers. In fact, separation attitude, the attitude of the Magellan spacecraft just after separation from the IUS, was at or less than half a degree from specified separation attitude. The folks at JPL are very happy with these numbers. The next major burn or course correction, as planned, will be conducted on May 21st with the first of 3 trajectory corrections. The crew was put to bed last night at about 10 hours 30 minutes mission elapsed time, and given 8 hours to sleep, are due to be awakened again in about an hour and a half at 18 hours and 30 minutes mission elapsed time, or roughly 8:17 a.m. Central Daylight Time. One of the first tasks the crew will set about after wake-up will be to maneuver to the proper attitude for aligning the inertial measurement units on board the vehicle. After that IMU alignment is performed, Just shortly after that IMU alignment is performed, a detailed test objective to demonstrate the suitability of the heads-up display located in the window of the forward cockpit of the crew compartment as a star sighting device for IMU alignments will be conducted. There are two markers in the heads-up display test pattern which can be used for optical sighting of stars. Both are of an appropriate size, and the plan is to use each marker during 3 different test periods in the early, middle, and late part of the flight for a total of 6 star calibrations. This should provide a reasonable base for establishing crew preference and allow some comparison between the 2 markers for dispersions and marker movement between the test periods. This test designed again to establish the suitability of the heads-up display as a star sighting device as an alternative to the COAS, which is currently used for star sighting and COAS calibration, which is in support of the alignment of the inertial measurement unit, which is performed on a daily basis. These tasks coming in the post-sleep period, after post-sleep and after the crew's had a chance to have some breakfast. The first secondary payloads operation of the day begins with the FEA Sample 1 activation. That's currently targeted for about 22 hours and 15 minutes mission elapsed time, beginning 16 hours of data takes and observation of that sample run. Those status reports and documentation, observation documentations, taken every 30 minutes during that 16-hour period. Also on day 2, we expect to record various MLE targets of opportunity. The mesoscale lightning experiment involves using onboard cameras and photographic material to document electrical activity and thunderstorms below. The crew will be looking for opportunities in the dark to document such activity in the atmosphere below. There are also 2 AMOS data takes scheduled again for Orbit 19 and Orbit 22 in conjunction with RCS Burns. Again, there is no flight hardware on board the vehicle to support the Air Force Maui Optical Site Calibration Test, or AMOS as it is called. The orbiter itself acts as a subject for ground sensor operations. We're now beginning to take data again through the Tracking and Data Relay Satellite West. This is Mission Control Houston at mission elapsed time 17 hours and 18 minutes. The orbiter Atlantis, currently in a 178 by 160 nautical mile orbit, currently at an altitude of 163.4 nautical miles as Atlantis nears the end of its 13th orbit. After a highly successful flight day 1, which saw the successful deploy of the Magellan Venus Mapper, flight planners on the planning shift have encountered a relatively quiet, uneventful planning shift, simply refining procedures and refining timelines for Flight Day 2 activities. During the course of the night, about 2:15 a.m. Central Daylight Time, the Magellan flight director from the Magellan POC in Pasadena, California, contacted flight controllers in Houston to let them know that trajectory numbers provided by the Deep Space Network, responsible for tracking the Magellan on its way to Venus, showed very, very close to specified numbers. In fact, the separation attitude, that is the attitude of the Magellan spacecraft just after separating from the inertial upper stage, was at or less than half a degree from specifications. Needless to say, the Magellan folks are very happy with that. Magellan, on its 15-month journey to Venus, will require 3 planned trajectory corrections, the first of which is scheduled now for May 21st. Again, flight planners here on the planning shift in the flight control room have prepared a small number of messages, 4 to be exact, shortly to be teleprinted to the crew prior to their wake. Those messages include minor flight plan timeline revisions, deorbit opportunities table, mission summary, and a payload operations checklist procedural change. That procedural change related to the FEA, or Fluid Experiments Apparatus. The first data take for FEA is scheduled for about 22 hours 15 minutes mission elapsed time. That will begin 16 hours of crystal growth in ampule number 1, during which status reports and status documentation will be made every 30 minutes. Again, the crew due to be awakened in about 1 hour and 10 minutes. First order of business for the crew upon awake will be to maneuver the vehicle to the proper attitude for alignment of the inertial measurement units on the vehicle. Shortly after the IMU alignment, the crew will conduct a DTO, or detailed test objective, to verify the suitability of the heads-up display in the windows of the cockpit as a possible star sighting device in support of IMU alignments. By using the heads-up display, or HUD, instead of the COAS, the crew will perform COAS calibration procedure 3 times, early, in the middle, and late in the flight. This procedure will provide a good base for establishing some crew preference in procedures for performing COAS calibrations and supporting IMU alignments by star sighting. Those at IMU alignment and the heads-up display DTO planned for the post-sleep period. Also, during the post-sleep period, the crew will have an opportunity to prepare and consume a meal. After post-sleep, they will forge into the Flight Day 2 timeline, consisting of FEA operations, a number of targets of opportunity scheduled for mesoscale lightning experiment data takes. Those data takes coming on nighttime passes, watching for electrical activity and thunderstorms below. That phenomena would be documented using both the onboard CCTV system and onboard photographic equipment. In addition to that, there are 2 AMOS data takes scheduled. The Air Force Maui Optical Site Calibration Test, otherwise known as AMOS, does not involve any flight hardware on board the vehicle. The orbiter itself acts as subject for ground sensor operations as the orbiter passes overhead over the island of Maui. The orbiter and crew will participate in conducting reaction control system burns, pitch yaw tests, payload bay lighting tests, and water dumps throughout the flight in order to allow for ground-based electro-optical sensors to collect imagery and signature data of the orbiter as it passes overhead. None of the relatively minor anomalies which were encountered on Flight Day 1 have been worked overnight. Those anomalies have been put to bed as non-impact items. The failure of a reaction control system jet has been tabled for the mission. There is plenty of redundancy in RCS jets that the loss of a single jet and that particular jet will create no impact on orbiter maneuvering, attitude control, or entry operations. the failure of a auxiliary power unit number 2 catalytic bed and fuel pump heater failed. The failure mode called for a switch to the B string heaters on the APU. The B heaters for APU2 are performing very well. Temperatures in the fuel pump, in the gas generator or catalytic bed, and the fuel lines all looking very good. Although we've lost redundancy in that heater system on APU2, again, the heater B is performing very well, and we do not anticipate any further problems with APU2. Another minor anomaly which received no action or work by the planning team overnight, but which will see some effort by the flight crew on flight day 2, is some jamming of the text and graphics system. A 20-page feed test conducted on flight day 1 resulted in paper jamming on about the 17th or 18th page, and rather than get into some extensive surveys and troubleshooting on that piece of equipment in the crew cabin just prior to crew sleep, the team opted to conduct some in-flight maintenance procedures early on flight day 2. Those procedures will include inspection for any contamination or debris that may be found on the head, as well as simply removing the paper and resetting the text and graphics system apparatus in the mid-deck and retransmitting the test pages again. We're now about 1 hour and 2 minutes away from waking the crew of Atlantis. Atlantis currently nearing the end of orbit 12. Atlantis now out over the South Pacific at an altitude of 169.9 nautical miles. Orbit 1 flight controllers beginning to arrive now in the flight control room to begin the 1 hour handover from the planning team to the Orbit 1 team. At mission elapsed time 17 hours and 28 minutes, this is Mission Control. This is Mission Control at mission elapsed time 17 hours 33 minutes. Our next television event is scheduled to be a change of shift briefing with off-going planning flight director Bill Reeves. That change of shift briefing is currently scheduled for 8:30 a.m. Central Daylight Time in the Building 2 briefing room. Those who would be interested in participating in this change of shift briefing should contact the Johnson Space Center News Center at area code 713-483-5111. In the event that little or no interest is shown in this shift briefing, the briefing will be canceled. Again, our next television event is scheduled to be a change of shift briefing with off-going planning flight director Bill Reeves. Those who have interest in attending or participating in that shift briefing should contact the JSC News Center. In the event that little or no interest is shown, that briefing will be canceled. This is Mission Control Houston at mission elapsed time 17 hours and 50 minutes, now taking live television from the payload bay cameras of the orbiter Atlantis. We're about 40 minutes away from waking up the crew. Atlantis just beginning orbit 13 and crossing the upper west coast of South America. This view coming from the camera A, located on the forward port location. Atlantis currently in a nose north attitude with the payload bay pointed towards the Earth. So this view looking across the tail of the vehicle southward down the globe. This is Mission Control Houston. We have a temporary loss of signal as we transition from the Tracking and Data Relay Satellite West to the Tracking and Data Relay Satellite East. Here in the flight control room, Orbit 1 flight controllers beginning their handover from the planning team. We're now about 36 minutes away from waking the crew of Atlantis. Planning shift has completed all the messages, completed the reviews, prepared them for uplink, and very shortly they'll be teleprinted to Atlantis. Orbit 1 flight controllers beginning to review that package themselves here in the flight control room with their planning shift counterparts. Some members of the mission management team trickling in and out of the flight control room, getting brief statuses before going off for their morning mission management team meeting.
Atlantis, Houston, good morning, and congratulations on a super day yesterday.
Good morning, Houston. We're up and around. Everybody's feeling good, trying to find their toothbrushes.
This is Mission Control, Flight Day 2's Wake Up Music.
Houston, Atlantis, we thank you for the fine wake-up music.
Atlantis, Houston, you're very welcome. And your planning team is happy to hand off to the Orbit 1 team. Your Capcoms, Mike and Dave, will be picking up for the rest of the shift.
Say again who our pals will be this morning.
Roger, you'll be talking to Mike and G. David.
Okay, well, thank you for those who guarded us during the night. We appreciate it. We slept very well.
Roger, our pleasure.
This is Mission Control. Flight Day 2 Wake Up Music was the theme music from Superman in celebration of a super day from the planning team Capcoms, Ken Cameron, the oncoming Orbit 1 Capcoms, Mike Baker and David Lowe. Orbit 1 team has taken over control of the flight now, completing their handover from the planning team. And we'll be expecting to have the change of shift briefing with the planning team flight director, Bill Reeves, at about 8:45 this morning.
Atlantis, Houston.
Go ahead.
Good morning, David. Like a couple of notes here, quick ones for you. Would you let us know how the teleprinter quality is this morning? And while you're doing your LIO changeout, we'd like you to check around for free water just to check to see if there's any floating around there.
Okay, we'll check for free water during the LIO changeout, and we'll give you a comment on the teleprinter quantity momentarily.
This is Mission Control. Dave Walker responded to the Capcom's request about teleprinter quality. Yesterday on Flight Day 1, the crew had reported that the quality of the teleprinter messages was somewhat degraded but still legible. And since Flight Day 2 execute package has been sent up to the crew in the last few minutes, flight controllers wanted them to look at that and see if the quality had improved. During the standard morning change out of the lithium hydroxide canisters, those are part of the air filtration system in the cabin air. The crew was asked to look for free water. This is...
Atlantis, the teleprinter looks fine. We just glanced at it. There's a lot to read, but looks like it's all legible.
Okay, great. Thanks, Dave.
Mission Control, obviously the teleprinter quality of legibility is fine this morning. The request to look for the free water is in response to some slight variations in the humidity inside the cabin that the ECOM officer has been tracking overnight. Normally the humidity factor stays fairly constant, and it's been moving back and forth 5 or 6 degrees. Currently, cabin humidity is 55.6% and has been coming up a little bit. There is some thought that possibly there's some condensate forming somewhere around the humidity separators. However, there's no data to clearly define that, and that's why the crew was asked during their...
Houston.
Houston, Atlantis.
Roger, we didn't get a good return tone. We'd like you to check to make sure that you got all 4 messages, 2 Bravo, 3 Bravo, 4 Alpha, and 5 Bravo.
Okay, we'll check.
This is Mission Control. The crew's also been asked to make sure they have received all their teleprinter messages that were sent up this morning. Ground controllers were not absolutely sure that every message got up. And we'll be looking to hear from the crew their findings when they change out the lithium hydroxide canisters as part of their normal morning procedures.
Houston, Atlantis.
Go ahead, Atlantis.
It looks like what we've got is 2 Bravo, 3 Bravo, 4 Alpha, 5 Bravo, and a resend on 2 Bravo.
Okay, great. That's exactly what we wanted to hear. Thanks, David.
Indeed.
Houston, Atlantis.
Go ahead, Ron.
Okay, Mike, we'll be doing KU antenna cable positioning.
Copy, thank you.
This is Mission Control. Our next change of shift briefing will begin at 8:50 a.m. Central Time with off-going planning team flight director Bill Reeves, and that briefing is scheduled for 8:50 in the Building 2 briefing room at JSC.
Houston, Atlantis, recom, as you've been watching the Cryo 2 heater checkout to post sleep is nominal.
Roger, we copy, Atlantis. Thanks. Atlantis, Houston, I have a short note on your R1U jet when you're ready to copy.
Go ahead, Houston.
Roger, we'd like to go ahead and put R1U into last priority and then reset the pod fail counter and do that on spec 23 by selecting item 20, deselect inhibit, and then the jet deselect item 21 twice.
Okay, we'll reselect jet R1U into the availability table, and we'll re-enable RM on that jet.
Ron, stand.
Last priority.
Yeah, we want to put them in last priority with the deselect inhibit, and then do the jet deselect twice to reset the pod counter.
Roger, understand. Understand.
Okay, great.
This is Mission Control. The discussion about jet R1U is for an RCS jet. R1U is the one that failed during the ascent phase, and up to now has been deselected so that it wouldn't fire at all. For purposes of the RCS, Reaction Control System hot fire test, which will be performed on landing day, the jet is being reselected and put into last priority.
Atlantis, Houston.
Houston, Atlantis, go.
Roger, for Ron on the R1U, we saw what you've done. We like that. We'd like you to go ahead and deselect that jet, though, with the item 21.
Okay, we'll deselect it.
Atlantis, Houston, it looks like the IMU maneuver is going to bring teeters close to the tail. We may have some Radicom here coming up towards LOS. Atlantis, Houston, say again.
Second.
Atlantis, Houston, comm check.
Loud and clear.
Roger, we're reading you the same.
Okay, and for info, it looks to us as though, and correct us if we're wrong, skimming this teleprinted up cap, it looks as though it's changed only very slightly from the regular flight plan. Is that correct?
That's correct, David.
Okay. And for info for the tags, folks, we've made several attempts already to clear the jam. It is, in the terminology we've grown fond of in my sim team, a dead kitty, and we don't think we're going to be able to fix it without completely disassembling the thing.
Okay, we copy that. And Dave, summarize the main changes in the cap are just for the FEA.
Okay, and Mary's got that message in her hand and is looking it over even as we speak.
And also, the Amos is 1 rev early on. It's 1 rev earlier on rev 18.
Okay, thanks. That's a good catch. We're still perusing for changes. Houston, Atlantis, how do you read?
Loud and clear, Dave.
Okay, we've got a background noise. It sounds like it may be on air to ground, excuse me, air to air.
Atlantis, Houston, how's this?
Yeah, that's quit. It sounded like a constant key on air to air, but it's gone now.
Okay. And Dave, Atlantis, Houston, we see you've got stars 31 and 50 in the table. We like the way those look. Your go to torque the IMUs with those 2 stars.
Okay, understand you like the stars in the table. Go for the IMU alignment. And we picked up this background hissing again, which we still think is associated with the air-to-air.
Okay, that's a good copy on the IMU line, and we're checking on that noise.
Houston, Atlantis.
Go ahead, Atlantis.
Yeah, Mike, for clarification, we've got more stars than the pair we were advertised to have in the table. You do want stars 12 and 31 as opposed to 31 and 50.
We go ahead. We like 31 and 50, David. You can go ahead and use those.
Okay, it's in work. Okay, Houston, starting the line at 123 seconds.
Okay, Dave, we copy that. And a couple of quick notes. During your tags troubleshooting, did you have the tags powered up? And if not, we'd like you to go ahead and power it up now. And also, we didn't see the -Y star tracker. We'd like to go ahead and pick that up after the COAS items are complete. And we'll talk about that when we pick you up on the west at 2012.
Okay, understand you want me to repeat the star tracker self-test on the Y tracker when I'm AOS?
Affirmative.
Okay.
This is Mission Control. We've completed the playback of Flight Day 1 television and have returned originating NASA Select Television from JSC with live views from the flight control room. Crew is moving on through the early portion of today's flight activity plan. There are a few changes to what the crew will be doing. One of the early tasks this morning was to try to unjam the text and graphics system. That's what we are referring to as tags. The crew reported they didn't think they could get the jam of paper out without taking the machine apart. However, ground controllers have asked them to make sure they had it powered up. and we expect to have a report from the crew about that later on. They have also performed their morning IMU alignment, and we'll be doing a self-test on the -Y star tracker after we come AOS on the Teeters West satellite about 5 minutes from now. Correction, that's we're going LOS in about 5 minutes. After we reacquire on Teeters West, they will complete that -Y star tracker test. Crew will also be setting up the fluids experiment apparatus for the first run today. And we'll be setting up some other experiments that will be running throughout the mission. Our latest reports from Magellan controllers indicated that at 8:15 this morning, the satellite was 169,287 kilometers away from Earth, moving at a rate of 11,176 kilometers per hour. Magellan flight controllers were very pleased with the status of the vehicle, and its trajectory was very near perfect. At mission elapsed time 20 hours and 3 minutes, this is Mission Control.
Atlantis Houston, with you through Teeters West.
And Mike, we hear you.
Roger, thanks.
Houston, Atlantis, reference tags.
Go ahead.
Okay, we've been working on the jam for some time. We had several different people try it, and we were able to get a small piece out of the right side in the back, and where it's jammed up is on the paper shelf in the back, so you can't even get the IFM tool back into that area. And it looks to me like there's 1 or 2 sheets that are jammed. We can go ahead and power it on and advance it, but it's not going to get us anything.
Okay, Mark, we copy that. Stand by. Okay, there's no need to power it on.
Okay, copy.
Atlantis Houston, Mark, we're going to be thinking about what we can do with the tags up. Until then, there's no need for you to do anything else with it.
All right, we copy.
Atlantis Houston, can you tell us how the LIO changeout went?
LIO changeout was nominal.
Okay, thanks, David.
Yeah, we haven't done one yet this morning. That was last night's we're telling you about.
Oh, okay, we copy.
If there are any changes to the procedure, we haven't encountered them yet.
No changes. We just wanted you to take a look around for free water.
Yeah, we got that note, and we'll look for free water if we see it. Do you have any reason to believe we have free water?
No, we've just been looking at some humidity is a little bit higher than we've seen before, but we don't suspect anything.
Okay, we'll do a good inspection in the bilges there in a little while when we get through some of this other stuff, and we'll get back to you.
Okay, thanks, Dave. Atlantis, Houston.
Houston, Atlantis.
Yeah, we've got some Timbus we'd like to send up their standard for the post-supply water dump, but we can't do it with the Spec 60 up, so we'd like you to resume Spec 60.
Okay, we'll do it. Houston, Atlantis.
Go ahead, Atlantis.
Okay, we've completed the HUD COAS Cal DTO, and we can do the -Y star tracker self-test for you real quick right now if you're watching.
Okay, we're watching. Go ahead and do that, Dave, if you would. Thanks. Wait a minute, stand by. Hey, Dave, we need to uplink some variable parameters first, and then we'll be ready to go. We'll let you know. It should be ready in just a minute or so.
Okay, well, you may miss it due to sunlight if you wait. We'll try, see what happens.
Atlantis, Houston, we've got the variable parameters up. We're ready for the Star Tracker self-test -Y.
Okay, it's in work. Okay, to us here, it looked like it did the same thing it did last time. You want one more shot?
Okay, we copy that, Dave, and we do not want another. We're going to take a look at the data. Thank you.
Okay, with your permission, I'll put it back in track.
Okay, Dave, you got to go to put it back in track, and we're standing by for any words you want to give us on the HUD DTO.
Oh, I understand you want some words on the HUD DTO?
Yeah, do you have any qualitative comments on how it worked?
Yeah, we sure do. Ron did that particular data take, so I'll let him tell you. Here he is.
Okay, Mike, subjective overall comment is that doing the HUD cal is at least as easy or probably easier than the COAS cal, and the reason for that is there seems to be a little more granularity in the ability to dim the HUD than there is in the COAS, and the green light background to work against is just a little easier. As far as the various candidate targets in the HUD test pattern, the one that I preferred was the upper right, the smallest circle, followed by the lower left, the medium-sized circle. Those were just easier than any of the lettering in the complete. Between the O and the P, my preference would have been for the P just because it made for a slightly smaller target, and I was able to get it more accurately. The results that we saw between marks were probably better than what I'm used to seeing using a COAS.
Okay, we copied all of that. Thank you, Ron.
And as a matter of interest, I went through it on the right side with him while we were taking the data, and the right HUD correlates very well with the left HUD. Hardly any difference in the marks. When he had one centered over there, it was centered almost perfectly over here as well.
Okay, copy. Thanks, Dave.
Houston, Atlantis.
Atlantis, Houston, go.
Roger, we're just going to change the BDAP to B2. We don't think we have any BDAP work between now and our AMOS, and that will call for the B2 DAP. So we're going to omit the step of reconfiguring B1.
Okay, we copy. Atlantis, Houston, I have a short note on your tags.
Okay, go with your tags note.
Okay, after discussing it down here, we have one last thing we'd like to try to do. We'd like to go ahead and power it on. That causes the roller to advance, and then we'd like you to attempt to remove that paper with the tool, if you could. And also, we like the B2 DAP, just as you said.
Okay, we've set up the B2 DAP, and we copy your instructions in work.
This is Mission Control. Pilot Ron Graby gave us a qualitative type report on the heads-up display detail test objective just completed a little while ago by Graby and Walker. That test consists of using the heads-up display as a star sighting device for IMU alignments, and the purpose of this test is to give some comparison between the use of the heads-up display and the use of the COAS or coarse optical alignment sight. Graby reported that using the HUD was just as easy or easier than using the COAS. Crew has also been asked to power up the text and graphics system, the tags, and try the malfunction procedure one more time using the in-flight maintenance tool to try to unjam the paper. Probably if this attempt does not work, we'll power it down and just won't try to use it for the rest of the flight. So this is another chance to see if they can unjam the paper. It appears to be stuck at the very back.
Go ahead, Atlantis.
We'd like to take control of the KU band power, put it in panel so we can power up our tags.
You have a go for that, David.
Roger.
Houston, Atlantis, reference tags.
Atlantis, Houston, go ahead.
Yeah, Mike, if you open up the MAL book to 2-58 where they have the picture of the tags, paper jam, let me tell you where it's jammed. These rollers that you're talking about are, well in front of where the jam is.
Okay, Mark, we're looking at the MAL now. Could you describe the rollers again?
Okay, back where it says paper shelf, if you go, if you're looking at the page, if you go to the left, right where the crosshatch area is, back by the developer assembly, that's where it's jammed coming out of there. So the rollers are well in front of where the jam is, and it's in the area where you can't even get the little jam clearing device, the forceps, back in there. They just won't fit.
Okay, we copy that, Mark. All right, Mark, we'd like to just discontinue working on the tags. You can power it off. We appreciate your efforts trying to get it fixed, though.
Okay, copy.
Houston, Atlantis.
Go ahead, Mary.
Just for your information, our iodine levels in our water, we were running 5 on the first container, 5 parts per million. First container we pulled off yesterday, and we're up to a healthy 11 parts per million this morning.
That's great. Thanks.
Houston, Atlantis for Inco.
Go ahead, Mary.
We have the TV cameras set up sort of simultaneously, and we'd like to explain the setup to you a little bit. Up on the flight deck camera is plugged into our camcorder. The mid deck is plugged into an orbiter TV, which will appear upside down because we had to sort of mess around with a bracket to get them to see the same scene, which is the mid-deck lockers. And we're just going to leave them set up like this. You're welcome to take TV and see whether you can work out our TV systems.
Okay, Mary, we copy that. We'll go ahead and do that. And Atlantis, for us to go ahead and do that, we'd like to take the KU control switch back to command.
Okay, we'll do that for you.
This is Mission Control. We're having some unexpected, unscheduled downlink TV from the mid-deck of Atlantis.
KU's back to command.
Roger, copy, Norm.
This is Mission Control. These are live mid-deck views from Atlantis, looking aft toward the lockers stored at the rear area of the Atlantis mid-deck.
Atlantis, Houston, we'd just like to let you know we are getting good TV of the mid-deck. Atlantis, Houston, we're going to be LOS teeter cease in about 30 seconds. We'll have you IOS till 2143. We'll pick you up on the west teeters at 2149. And just for your information, your UHF background noise that we had earlier was due to your location in the orbits because of some local area problems. It's not an orbiter or an MCC problem.
Hey, Mike, what's up?
Mike, are you done with the in-cabin TV?
That's affirmative. We're done with that.
This is Mission Control. Our next TV will be a replay of the camcorder test that we just had live downlink from Atlantis. The test was a comparison of television transmitted from a regular shuttle TV camera and the camcorder that's being checked out on this mission. And that's why one field of view from one camera was upside down and one was right side up, to let us know the difference between the two so we could evaluate the quality of the transmission. The crew will be losing signal through the Indian Ocean ground station in about a minute, and we've lost signal through Tidris East. During the second half of this last Tidris pass, the crew tried one last time to unjam the text and graphics system, but no joy. Using the malfunction procedure and the in-flight maintenance tool, they were still unable to release the paper that's stuck in the machine, so it was powered down and will probably be just shut down for the remainder of the mission. Also, Ron Graby gave a report on the completion of the heads-up display detailed test objective using the HUD as another device to sight stars prior to IMU alignment, and he reported that that was quite easy and a satisfactory way to line up with stars. Mary Cleve reported on some water quality numbers. This evaluation is of particular interest to Mary. It's neither a DTO nor a DSO. It's merely an engineering evaluation. There have been some comments from previous shuttle crews that the water is slightly discolored or doesn't taste too good, the potable water supply. And it's thought that perhaps the iodine content is the cause of that. Mary has on board 10 containers to which she adds the drinking water, and the starch in this container turns color, and she's able to compare the color of the contents of the drinking water container with a chart she has on board. And this tells her the iodine content. The iodine content is not a medical concern nor any kind of safety concern. It's simply a matter of how the water looks and how it tastes. So this item is of particular interest to Mary Cleve with her background as an environmental engineer. It's up to her discretion how often she checks the water, and so far she has done 2. And we'll might hear comments now and then through the rest of the mission about those engineering evaluations of the drinking water. At mission elapsed time 21 hours and 45 minutes, this is Mission Control.
Atlantis Houston with you through Teeters West.
Atlantis, roger.
Atlantis Houston, I have some FEA notes from Mary.
Okay, stand by. We'll try and get her.
Houston, Atlantis, ready to copy the FAA notes.
Okay, Mary, it's just a heads up. I think you've probably figured it out, but since you're going to be using sample 3 processing procedure for the sample 1 down there in step 1, you can ignore the previous heater power recorded value and just use the stabilized melted zone paragraph to complete that step. And then make sure you note the final heater power so that you can use it later on for your actual sample 3.
Okay, we copy that, thanks.
Houston, Atlantis.
ahead, Dave.
Okay, we've done the LIO changeout, and I looked around pretty carefully in all the easily accessed under the deck kind of compartments, and without pulling some fasteners, I can't get any closer to the water tanks than I am right now, and I don't see any evidence of free water.
Okay, we copy that.
If the humidity continues to be something of concern, we can always get down closer to the tanks.
Okay, yeah, we'll be keeping an eye on that, and there's no problem right now. We appreciate taking a look around.
No problem.
And Dave, for your Atlantis Houston, we're going to be LOS Teeters East in about 30 seconds. We'll have you IOS till 2143. We'll pick you up on the West Teeters at 2149. And just for your information, your UHF background noise that we had earlier was due to your location in the orbits because of some local area problems. It's not an orbiter or an MCC problem.
Okay, Mike, we'll copy. Mike, are you done with the in-cabin TV?
That's affirmative. We're done with that.